Hey yo, it's dream number 294, and I'm just a few minutes early here. Thought I'd get some starting up the stream stuff out of the way before 10. I always forget something. Now I'm trying to figure out what I'm missing. And I'm looking at this thinking, shouldn't this be higher up? Maybe it's no, okay, where it is. I'm so picky sometimes. Okay, so today's going to be hopefully catching up to day 17, which is the current day of the Advent of Code Challenge for 2019. I should probably say 2019 there. So I left off at the end of day 14 last night, and I'm starting on day 15 today. Yay! And if I'm really lucky, I'll get through all the way to the end of day 17, and I'll be waiting for day 18 to be released in 11 hours from now. So by the end of my stream, it'll be 7 hours, which means it'll be for me in the evening, like 8 o'clock, 9 o'clock. And I have to decide whether or not I'm going to actually try that challenge. And actually, I wanted to review the rules because it occurred to me that if I stream live Puzzle 18 when it unlocks and I get it done within the top 100, probably wouldn't happen. But let's say it does, right? Can't people immediately clone my code, run it, and then score within the top 100? Wouldn't that be cheating? Hey there, TS Jaws. How are you doing? So I'm wondering, is it a good idea to stream when the puzzle unlocks or not? Yeah, 14, 13 were last night. 14, which one was 14? 14 was interesting. Part 1 was really easy, but then part 2 was a little tricky because it had to do with handling remainders of byproducts. And I treated this as just a dependency tree that we had to walk in reverse to find out how many ore you need to get one fuel. Many people are streaming, so it's fine and posting their code. Yeah, but once, let's say a top 100 person posts their code, can't other people just immediately clone it, run it, and then score in the top 100? Kind of like, I don't know, code parasites? What's to stop that from happening? They can, but do they? That seems sort of messed up. I think the top 100 should be just people who have genuinely done the puzzle within themselves and not like copied from their friends or whatnot. Anyway, let's start looking at puzzle 15-1. But a lot of people are doing it, so it's fine if you stream. I guess so. All right, out here in deep space, many things can go wrong. Fortunately, many of these things have indicator lights. Unfortunately, one of those lights is lit. The oxygen system for part of the ship has failed. According to the readouts, the oxygen system must have failed days ago after a rupture in oxygen tank 2. That section of the ship was automatically sealed once oxygen levels went dangerously low. How convenient that that happened. A single remotely controlled repair droid is your only option for fixing the oxygen system. Why can't we hold our breath and then fix it? I don't know. The Elves Care package included an encode program, your puzzle input that you can use to remotely control. I should start my timer, by the way. Yes, I should. Remotely control the repair droid. By running that program, you can direct the repair droid to the oxygen system and fix the problem. The remote control program executes the following steps in a loop forever except a movement command. Via input, send the movement command to the repair droid. Wait for the repair droid to finish the movement operation. Report on the status of the repair droid via an output instruction. Only 4 movement commands are understood: north, south, west, and east. Any other command is invalid. The movements differ in direction, but not in distance. In a long enough east-west hallway, a series of commands like 44443333 would lead the repair droid back to where it started. Repair droid can reply with any of the following status codes. It hit a wall, and the position is not changed. Has moved one step in the requested direction. Has moved one step in the requested direction. Its new position is the location of the oxygen. Oh, we're going to be doing a maze. I love it. Hey there, Voint Comp. Is it cheating? Let's think of a different scenario. What if you paid someone to solve the puzzle for you? No one would know, and you would be world famous. I guess. Yeah. It's a possible weed out the cheaters. If someone wants to cheat, they'll find a way. That's true. It's one of those facts of life, I guess, right? We're going to be solving a maze. Isn't this fun? You don't know anything about the area around the repair droid, but you can figure it out by watching the status codes. For example, we can draw the area using D for droid. Pound sign for walls, dot for location that they can traverse, and empty space for unexplored regions. Initial state looks like this. You tell it to go north. So there's a wall there, up wall, and then move east. And then more attempts, and we find the walls. Yep, now he's going to be bouncing off a lot of walls today, isn't he? Now the repair droid is in a dead end, backtrack, then perhaps west. Got it. Now, because of the reply of 2, you found the oxygen system. Yay! In this example, it was only 2 moves away from the repair droid's starting position. What is the fewest number of movement commands required to move the repair droid from its starting position to the location of the oxygen system? So, we have to do 2 things. We have to basically find the oxygen system through a maze. So, it's exactly the way this is doing it, pretty much. It's exploring until we find it. And then once we find it, we have to do a path find from our original location to the one we want. Fortunately, I have a pathfinding set of code that will find the optimum position. So I don't think it's cheating. I just happen to have code for it. So we'll just pull that in. Sound good? You haven't even attempted this one yet? Yeah, you can use it. I know. Isn't that cool? Hey there, Rowdy Monkey. Okay, let's begin. So I need a copy from the last time we did int code. It wasn't 14, right? All right, that's the ore stuff. What about 13? What was 13 about? That was the Pong game. That was fun. 12 was the Moon 1. Yeah, it's been a while since we used our int code compiler, or int code program. This one, yes. So we're going to take 11.2 and copy it and call it 15.1. And open the make files, 15.1 and 15.1. There we go. Hey there, Nui. Breakout game, not Pong. Yeah, you're right. It's Pong, but with 1 paddle and then bricks, I guess. Pong would be 2 paddles and maybe some bricks, but usually not. And 2 players. Alright. I think I get them confused because when I first played Pong and Breakout, they were on the same game system. They were just 2 different modes of the same game system. Alright. I don't have a terminal window open. Let's open one. And we're going to set up to check in stuff as we go. Build 2019 15.1 and copy 2019 15.1 input example input. So it's just replacing this is a copy of the one where we were painting a registration number on the hull of the ship. A new con EMU update is available. Yeah, one has been available for months. I'm like, it works for me, why update? I wish I could tell it stop bothering me. I've dismissed it saying to skip it, but it just comes back the next time anyway. Alright. So, let's see what I can keep and what I can toss. Position is nice because we can just have represent our maze using that. All of this is the same. The machine is the same. Maybe Windows updates are you behind on? I am a year behind. I'm at the maximum, so I will have to update in October next year. Because they give you the window of 2 years, and I'm like 1 year into it. I'm not on the bleeding edge because I think that's lunacy. So I'm as far back as I can be, which is a year, without like going through enormous effort. Okay, everything is the same up to construct machine, right? And then after that point, we're doing something different now. We're going to have to keep track of the maze, and so yeah, every position in the maze will be one of 4 values, right? I haven't been using an enum, but maybe I will now because I feel like it. So, explore the, what is it called? Section of the ship. So explore the section of the ship until the oxygen system is found. And so we're gonna have enum class cell. Let's call it a cell today, just to be different. So one will be unexplored. Actually, if it's unexplored, it won't even be in the map, right? So it'll be explored. It'll be basically floor, wall, oxygen system. Oh, look at that. You put a Christmas hat on my head. Nice. I don't know how to do that yet. Is that using the channel points and modifying the emote? Oh, hey there, Pro Sam. I didn't notice you. Hi. All right. This is the enum I'm going to use. So now I'll have a... Actually, I already have a map there. There we go. It's just going to be a cell here. Cells. And I get rid of orientation. The robot does have a position now. And presumably, the robot starts out sitting on the floor, right? Yeah, so there was a floor there. So we can say cells robot. Actually, we can always say this inside the loop, so take that back. Run the machine, providing as input the a command to move, right? Providing as input a command to move in one of the cardinal directions, and taking as output the response from the robot about what it encountered. What about the 10,000? I already sent it. Don't you remember? Don't you remember? I sent it to you. Hey there, Pollux. Uh-oh, you're in backwards land. I'm doing well, Pollux. How are you backwards? Sorry, I can't say things backwards, so I'm assuming you'll just take what I said and run it through a backwards fire, and then you'll understand what I said. You solved part 1 of this puzzle, such a relief. You're honestly scared of part 2? Uh-oh. Monkass. You think this is going to be hard? Yeah, Riley Monkey. I already sent it to you. In fact, I sent you too much. I sent you 20,000. You owe me 10,000 back. In Google Play cards, please. That's a Kitboga reference. All right. So, we might as well remember the bounds of the maze so that we can print it later. And we're going until it halts, right? Does it halt when it finds the oxygen system? I don't think it does. I expect it will never halt. It'll just tell us that it found the oxygen system. So we're just going to repeat. Okay, we'll have a flag here. Oxygen system found. While we haven't found the oxygen system, I suppose we'll go to an unexplored direction. So we'll take the robot's position and then look in the cardinal direction. So let's build that up. I had that in another example, didn't I? Like a 0, comma, -1 somewhere. Aha, I did. All right. In fact, I think it was all, I copied and I deleted it. So it's not gonna need to be a structure, really. It's going to just be a position. And it'll be directions. And then I can get rid of those and these. And let's align it to fit the input command. So 1 is north. This would be east. This is south. And that is west. And they went in a certain order, right? North, south. west, and then east. Okay, so that's 1, 2, and 3. No. 1, 2, 3, and 4. 15.2 is easier than 15.1? That's good. Oh, you read it as that? Yeah. It's the comp. It's like sticks in your head and is associated with that other word. All right. Okay. North. Okay. Got it. Okay. So, I think we'll just do simple flood fill. We'll just always try to go to an actually, no, I can't just do a flood fill, can I? I'll do the classical maze explorer where we keep breadcrumbs of where we've been and we try to go in a direction we haven't been. Actually, the breadcrumb could just be that we saw that there was a floor there before, right? And if we hit a wall, we'll have to backtrack one and then oh no, we'll need a breadcrumb trail because we might get into a situation where every direction is a floor and we'll be like, well, which way do we go back now? So we'll have to keep a trail in here. So let's make that a stack because we can. And stacks are fun. I hardly ever get to use a stack. A stack of positions, trail. So I think we'll just be dumb and look in all 4 directions for an unexplored spot, and if we can't find it, then we'll backtrack. So cells instead of panels. Cells entries find robot position. Okay, no, we need to do this in a loop. 4 size T. Eyes, 0 eyes. Actually, let's use ints so it's convenient. Int. No, size T is more appropriate. Is less than, if I make this a vector of positions, then I can use the size method, which is nice and convenient. For 15.1, you implement algorithm from German Wikipedia only to switch to English Wikipedia due to more explicit variables in the pseudocode. Is it a Blade Runner thing? I don't know. I haven't seen Blade Runner. Hey-o. Hey, Toulouse. How you doing? Had used wrong account earlier. Oh, did you come in with failed? Oh, I see that. I didn't see your chat, though. How come I didn't see your chat? Oh, there it was. I'll give you a hey even though you're using the wrong account. Okay, so I think we're just looking to see if anything is free. So from the original 1982 Blade Runner. So Voidcomp, Raleigh Monkey told me, was it a month ago, that the date in the movie, the original 1982 Blade Runner, like it actually just happened recently. And I'm like, wow, that's crazy. And he's like, okay, so where are the flying cars? I'm like, yeah, where are they? The movie promised there would be. Yeah, November 2019. Yep. But there was a specific date mentioned in the movie. So on that date, he like whispered me saying, hey, it's Blade Runner Day. Yeah, we already had it. Yeah. Okay. I actually want the variable after we leave the loop. So actually, let's reduce it to input. And if it's 0, that'll mean that we need to backtrack. So you know, would be easier for them to make the trail instead of a position. We can make it a direction. So it's a direction to go. Or actually, better would be an index into that directions thing. Because we can both turn that into a command by adding 1 to the index, and we can also just add that to the robot position that we're maintaining. Okay, so input is 0. Fine. So if cells entry is non-equal to cells end, and actually if it's equal, then we haven't explored it yet, and so we will say input is int I plus 1 break. And if we get out to the end, if input is still 0, then we need to backtrack. So if we did not find an unexplored cell next to the robot, we need to backtrack. So this one is look for an unexplored cell next to the robot. So if we need to backtrack, I will just get it off the stack here. So input equals we'll make these reversible, right, by subtracting or adding 1. So it'll be trail dot top oh, thank you for the follow, Sai. Hey there, Z Real Big Deal and Manir. How are you guys doing? Hello? Yeah, so working on, as it says above my head, Advent of Code 2019. Actually, I should probably just say that, because, you know, I could be working on, how come the current... Did I close the... No, I didn't close it. I could have said I was working on Advent of Code from last year, but no, I'm working on this year. I'm just still trying to catch up. So I'm writing the code right now for this puzzle number 15, which is to control a robot to try to explore through a maze and try to find a goal. And you command the robot, you interact with the robot through a special virtual machine that you build up. Over the course of Advent of Code 2019, we've been building up this machine, struct machine, which in the instructions they call an int code computer. And it's essentially a basic virtual machine which with only a few different opcodes, add, multiply, input, output. These are branches, these are comparisons, and then there's relative memory indexing. That was the most advanced part of it. And we're using that now to control a virtual robot exploring a maze. So in this case where we need to backtrack, I want to take the direction we took before and subtract 1 to go backwards, right? And then that's all I need to do. So, no, I need to pop the trail. The trail shouldn't be empty. If it is, that means we couldn't find it. Maybe I should have a special check for that. If trail.empty, then fprintf, standard error, feels bad man, could not find the oxygen system. Sorry, dude. And then return exit failure. That'll probably never happen. Okay, so now at this point we have an instruction for the computer, so we're just going to input it. So provide the robot with its instruction and run the machine to get the next output. So machine.input.push back input. Whoops. It's like my hands have dyslexia. And then machine.run to get the output. Where's the output? There's the output. Okay, and then we expect back something, one thing, right? It'll reply with that before, or yeah, so we should get one thing. So if the output size is not 1, robot did not provide correct output, right? And so we have to check based off the output, did the robot move or not? And if it moved, did it find the oxygen system? Actually, does it move? Yes, so it can move and find the oxygen system. So we're switching on the output, right? Switch. So use the machine's output indicates what happened to the robot and if it located the oxygen system. So switch on output 0. So they told us it would be a 0. It could be a 0, which means hit a wall. Cannot spell today. Actually, that's me all the time, right? I need to slow down and maybe do some keyboard practice. Moved in the... So, robot moved. Did not find oxygen system. And then there's case 2. Robot moved. Did find oxygen system. Actually, let's just make it a little bit more clear by just striking this phrase here. Robot moved, and found oxygen system. And then we should have a default case, which is the robot went insane. So fprintf Mr. Destructoid robot is insane. Beware human. Return exit failure. Alright, because just being corny. That should never happen. So, if it hits a wall or not decides whether or not we actually move. So, instead of doing that, we're actually moving that, right? So, if we hit a wall, then it's the robot position plus the direction of its input. Actually, no, it's not input. I need to actually get the direction out. Let's get the direction out right here, I guess. So const auto target position, we'll call it, is the robot position plus directions, and then it's size t I minus 1. It's input minus 1. Oh, by the way, we have a beast on cam now, or straight to the left. Beast cam enabled. That's my kitty. He's on his kitty tower, and I'm happy he's choosing to sleep there these days because now you guys can see him. What's wrong here? Do I not have a plus? I don't have a plus for position? Oh, I have a plus equal. Okay. So I can do that and target. Actually, I can implement plus. Why not? Plus is like plus equals. Hey there, Jesse. Exactly. He's a cool cat. So this is going to return a new position, right? So sum, I guess. And we'll make it start with this. Actually, this is supposed to be implemented as a friend or something like that, right? Or with 2 arguments. Actually, I think this way works too. In fact, I can be clever and say auto return sum. Actually, I'm not going to be clever. Let's be explicit. Return sum. Sum.x plus equals other x. There we go. How are you doing, Jesse? Let's see. So I have target position, right? So with the index, we had taken and added 1 and made it an integer, because that's what actually the input is actually int max, right? Yeah, I should be using int max t for that, just to be consistent in the type. So converting back, we subtract 1 and make it a size t again, then index directions, add the robot's position, and we get the target position. So the target position is a wall. Cell wall. I've been pretty good, Jesse, thanks. You're way behind on admin code as usual. Hey, but you can catch up. I didn't start until, let's go back. I didn't start until day 13. So on day 13, I started at day 1, and I did the first 4, and then later I got hooked. I did 5 through 10, and then I did 11 and 12 yesterday during the day, and then I did 13 and 14 in the evening, and that's where I am today. So I'm catching up. So even if you started on day 1 now, you'll only be 2 days behind me in real time, and you could definitely catch up. You still have hope, yeah. So, like, if I started today, I'd be where I am now on day 20, and I'd still have time. I'll at least have, for me, hopefully, 6 days at least where I can try to score points. So yeah, the thing about Evident Code, if you don't know anything about it, is they release a new set of puzzles every day. And the moment it gets released, everyone gets to see it. And the first 100 correct solutions get points on the leaderboard. So since I'm behind, I'm not getting any points. But I'm catching up, right? So once you get under rank 101, you start to score points. And that then you have bragging rights on the leaderboard. If you're so inclined to do speed coding. You've returned. How goes it? I'm still writing out the solution for exploring the maze, so you haven't missed anything big. Hey there, Shade. You wish C++ had a package manager for getting some libs to make it more easy. Yeah, I think a lot of people wish that. That's one reason that I don't really suggest C++ for a first language, because you have to look at this old style source mixing, which is done by the preprocessor. And a lot of people think of it as like an import, but it's not really. And there are lots of like bugs and problems that can result in not understanding what this actually does. It's an older, inferior system. Newer languages don't do it this way. They have a more feature-rich and easy-to-use library mixing and dependency declaration system. C++ is really old, and so this is just mixing in source code and doesn't help you at all as far as actually linking or building things. They're making some kind of C++ package manager thing. So you're saying, TS Joss, they're trying to fix the mistakes of many decades? That's one side of the camp, I guess, is to say that the language shouldn't be really involved in how packaging works. But then I can understand the other point of view where the language is a part of the tool set to make programs, and it can cooperate in package management. So yeah. You don't want to have a fractured ecosystem. You know, I think everyone's got a different opinion. Yeah, so yeah, literally what pound include does is the preprocessor says, let me find a file with that name, open it, read all of the lines from that file, and dump them on that line. So if you run this through the preprocessor, you'll, instead of getting a 424 line file, you'll get like tens of thousands of lines, and most of it will be the contents of these standard headers. And knowing that, you'll realize that it's just pulling in a lot of declarations. And sometimes it pulls in code, so like there are templates in C++ in these headers, you're pulling in code too. But a lot of these old style C headers, they're just declarations saying that, hey, yeah, there's a function called printf somewhere. And then the compiler says, yeah, you'll need printf. Yeah, go find it find it, you'll need it. And it's up to the linker to actually find the actual code for printf. And a lot of times the compiler and linker will coordinate by the compiler will send in hints to the linker saying, yeah, for printf, you'll probably find it in something called, standard IO something. It really depends on the compiler and the linker implementation and all that, but, you really can't depend on that unless you know what your implementation you're targeting. But anyway, yeah, so there's like a fracturing, so to speak, between the header files and the actual library where the code is. And depending on what tools you use, you have sometimes it just works, and other times you have to figure out what library path do I need? What do I put on the linker command line to actually get everything to link? C++ 20 introduces modules which fix a lot of this stuff. So yeah, so they're picking up the more modern concept of having the compiler be involved in the linking process, so to speak, or the dependency system. And I think that's a good thing. Let's see. Yeah. Oh, you don't want a fractured ecosystem. Got it. Yep. Okay, so moving on. Here, when it's a 0, we hit a wall, right? 0 is wall. Position is not changed. So we just mark what's there. Robot moved, if it's here. So we know two things. That it is a floor, and that the robot is now there. So robot position equals target position. And if it's a 2, we know 3 things. It's a oxygen system, where the robot is standing on it now, and oxygen system found is true. Okay, in addition to this... Oh, I'm being raided by Mr. Halsey. Hey there, Mr. Halsey. How was your stream? And hey there, Mempo. Mempo edits. Oh, and iGrok was here too. iGrok. Said VC Package and Conan are not too bad. I have those in my notes to research when I have the time. Oh, and Red Sky 1 said hello a while ago and I missed it. I'm sorry. Hi, Red Sky 1. Yeah, Mr. Halsey, thank you for the raid. I'm working on Advent of Code 2019, day 15, so I'm catching up. I'm only a couple days behind now. Waiting on an ad. Okay, let me know. Let me know when ad done. Thanks for raid. And, oh my goodness, what's that? Atomic Nibble, thank you for the subscription. Thank you for using your Twitch Prime on me. I'm so flattered. Thank you for your support. Hello. So, let's see. I am going to need to expand, yeah, this expansion stuff, but I don't want to do robot position because really target position is what matters. So expand our knowledge of the bounds of the maze with the target position. There's no such thing as robot orientation anymore. Do we bother printing what the robot finds, or should we just print out what the maze looks like at the end? Ad done. Well, thank you for the raid, Mr. Halsey. How was your stream? Back to the game? No, I'm still doing Advent of Code. I think I want to catch up at least, and then I'm not too sure whether I want to actually stream the current day's Advent of Code, or maybe just go back to doing my probably end up going back to working on my game. And if I do Advent of Code on the same day that gets released, I'll probably do it either in evening stream or I'll just not stream it. So yeah, I'm having just too much fun. It's kind of a holiday break to work on these challenges, I think. Also, I think people find it interesting, and other streamers are also showing it. So I'm showing you how to do it in C++, at least the way I do it. Not claiming I'm the best at it, but there are other streams out there showing how to do these same puzzles in Python and Rust, I'm sure. Got to be someone doing it in Rust, right? So yeah, it's cool. All right, let's actually move this to... Let's just put it here for now. Robot found a wall at... And let's replace robot position with target position. When these types are ints, okay, good. And so, let's say robot moved to. And let's also print out if the robot is backtracking. Robot is backtracking. We can also, I guess, print out how many... Oh, wait a minute, I put that in the wrong spot. It's right here. Robot is backtracking. Trail is length. That. And so I'm just curious to see what it is. So this would be trail dot size. Hey there, Indorn. How are you doing today? Many people, including yourself, did print the visible map after each step. I'm not going to bother because it's just going to flood fill it. What I'll do is I'll print the map if... yeah, I'll print the map at the end. Why not? I can move it around too. Oh yeah, that gift thing. I don't know if it's permanent or if it's just for December, but whenever someone subscribes or resubscribes, it hands out some special holiday emotes to 5 people. So, interesting. Sending up your VPN so your sister can copy your pictures to your server as a backup. That's good. Sounds cool. All right. I guess we should print out when we... Okay, what is this loop? I guess, yeah, we're printing out here. Found the oxygen system. And let's, yeah, we already have the code here. Let's use it to draw it. So we're drawing... let's base it off of the enum, right? It was floor, wall, oxygen system. So floor, wall oxygen system. And right, it's not a color. I guess it could be. We can just convert it to int. Print it. Okay, let's see what it does. Yeah, look at that. You've modified my hay to put a nifty Christmas hat on my head. Nice. It ends in January. Okay, sometimes you can keep up to 3 of them. That's nifty. Let's see what this does now. Robot did not provide correct output. Uh-oh. Oh, did I not copy? I didn't copy the example. I didn't even download it. It is at the bottom, right? Puzzle input. Here it is. So 15.1 example input is there. Copy it. Okay. Well, it's finding some things, but it's going really fast. Oh, no, the coordinates are all wrong. Okay, so I messed up. Let's look at that in the out and then see what I did wrong. So build 2019 15.1 out. Okay, it's just trying the same direction over and over again. So it's in the code here, I think, where we're trying to look for the next direction to move. Oh, I'm dumb. I don't want to look at the robot position. I want to look at the robot position plus directions I. There we go. Cannot find the oxygen system. Oh no! Let's look at it. Okay, but it didn't print it. Oh, did I have it just exit if it couldn't find it? Yeah, so it needed a backtrack, couldn't. Let's break. And let's move this found one in here. So that we can actually see it. Alright. Okay, that doesn't look right. Alright, so maybe I do want to print what the maze looks like every step. Yeah, I must have screwed it up. So this is probably why people are drawing the maze every step. Draw the cells in the ship. Well, that's cool. That's the first time my my cell phone provider now has this thing where they like I don't know how they do it with maybe machine learning or whatnot. They kind of give you an indicator of if the phone call you're receiving is spam or not. So the caller ID said potential spam. I'm like, okay, not gonna answer it then. Let's move that to after every step, I guess. So right. Yeah, right here. And let's overlay where the robot is. Actually, we can just overlay. No, I know what I'll do. We'll have a special thing if the robot is on the spot. Yeah, so if robot position equals position XY. Is Yashram to quickly report the spam? Oh, cool. Yeah, and no, you're a spammer. I'm not going to answer. Is this the solution that FCC came up with? I don't know. Nifty gifty, yay. And hello, Crystal Coder. All right. If that's that, then I'm going to use an index that we don't usually have, and I'll put the robot there. Let's make the robot look slightly different. And now let's output it. and see what it looks like. So at the very beginning, it moved up 1. Wait a minute. And then it found a wall at 0, 1. How could it find a wall at 0, 1? So the robot position wasn't updated? Let's print out the robot's position at the end. Actually, it should have said robot moved. Oh, robot isn't moving. Hold on. I messed this up somehow. Oh, this should be min x plus. We should just have that as in a position here. Const auto position, or const position, and then put these calculations in there and just make that position and then use that position there. There we go. So it wasn't plotting it correctly. All right. Found a wall. Let's print out some space so I can see this more easily. So printf, a bunch of dash. And then at the end as well. C++ is the best? Well, hey there, John Hillington. I like C++ too. Mostly because I've been using it forever. Okay, found a wall. Found another wall. Moved. Uh-oh. That shouldn't happen. Oh, I'm plotting, I'm expecting that, yeah, that's the problem. The default is that it's a floor. So let's add an unexplored in here. So that can be unexplored can be a space. And then this would be a 4. All right. So the robot moved. Oh, it didn't put a floor where the robot was. That's a problem. I'm always dissing C++. I love it and hate it. Of course, it's a bloated language. Yes, exactly. Love-hate relationship. RAII is why C++ is the best. Well, that's cool. I think everyone has a different reason why they like their favorite language. Okay, it didn't put a floor where the robot started. I think it's just because I forgot to do that. Yeah, we need to populate cells robot position. Obviously starts on the floor, right? That probably wasn't it, though. Nope, still can't find it. All right, so there's a floor there. So it's moving down the hallway, and then it was actually able to turn and go up. Found a wall, and then went left. Found a wall. Found another wall, left. I mean, it looks like it's exploring it correctly. It's preferring to go north, and then it goes north, and then it tries south, and then it tries west. So it's going to end up going west a lot of the time, or northwest, right? I bet the problem is when it has to backtrack. What term did I use for backtrack? And there should be a back. Okay, it's not back. Oh, I never fed the trail in. I'm dumb. So it got to a dead end and didn't know how to back up. Probably. Where is it? It's here. It got stuck. It got stuck in a corner and didn't know how to backtrack. All right, so we need to actually push onto the trail every time we move, right? Yes. I guess I can do it in 2 places. Actually, if we find it, we're gonna stop anyway, right? So I only really need to do it here. Yeah, trail dot push, and we're pushing the direction we went. So that is input. We're pushing the input we gave it. What? Did not provide the correct output? What? Oh, it halted. It halted for some reason. Your issue with C++ was always the include files. Yeah. Like we were talking about before, these are just directives to the preprocessor to replace each one of these lines with the contents of the file named here. And that can be abused horrendously. Another thing that could be abused is this ifdef. So a lot of languages like C# will allow you to use ifdef in a very limited way, like only if it's like ifdef debug kind of a thing, because it's been horribly abused. And it becomes a huge mess, yeah. Cut the cord on 32-bit? Yeah, maybe. It's about that time. Does anyone have a 32-bit machine? Well, hold on. That's true if only for PCs, but you have to remember that C++ is still used on a lot of embedded targets, and some of them are still 16-bit. In fact, I think some of them are 8 bits even. So on a very, very small microcontroller, you could run C++ if you're willing to your int be 16-bit. So I think it's conditional. You can cut the cord on 32-bit if you're only targeting the PC. Yeah. Embedded targets are fun, where it's like, oh, my ints are 16-bit. Oh, great. So I can, how do I do big numbers again? You have to have vectors of ints. Okay, what happened here that we were backtracking, we ran, and it halted. Is it that I don't have a halt check? Yeah, okay, so the machine halted for some reason when it was backtracking. Why did it halt? Oh, we were backing out of that corridor, and I probably gave it a bad input, right? Oh, I know what I did. I just subtracted 1. I shouldn't have done that. It probably gave it a 0. So when we backtrack, I have to actually flip the 1 bit, not subtract 1. Right? No, no, no. I have to either add 1 or subtract 1. Let's just have a map here. Yeah, we'll just make this a structure like I had earlier. Static struct. Actually, that means it's in 2 places, right? Struct direction. And then there'll be a position in it. Delta, I guess we'll call it. And then we'll have a size t of back. So this will be a vector of those. And so each one of these will have the position in it, but then it'll have the index of how to go back. So that will be a 1, and that will be a 0. And this will be 0, 1, 2, so that's a 3, and then a 2. Just to reverse the direction, right? Okay, so fine. So this is directions dot delta. And then this is dot delta again. But then when we're laying our trail, you know, I think I'm going to just have the trail, to be more easy, I'm going to have the trail be an index into the directions. So, actually it was. I just did it wrong. Okay, so when we pop it, it's not the input, is it? It's converting that into an int. Thank you for that follow. We need to say directions that index dot back, and then we're taking that as a we're taking that and then converting it into an int. Exactly. And so hey there, Dev. How are you doing? So we're not pushing the input anymore. We're pushing Oh, I hate these plus ones, minus ones. I should just have two variables here. Actually, what I should just do is encode into here the input. Then I can get rid of the type conversions too. So there's an input which is 1, 2, 3, and 4. And then we won't record the input here, we'll just pick a direction. So that's size t direction. I just have to be careful here that it's not 0. I guess we'll just have another flag to make it explicit. Direction chosen. And we'll set that to true if we find one. So this is direction equals I. And then if not direction chosen, then we need to backtrack. And when we backtrack, we are saying direction is directions trail top back. And then what we input is directions input. No, directions direction input. And then we push onto the trail just direction. And then what's wrong here? Oh, because min_x is the wrong type? Hold on. Oh. Some syntax error. Oh, this is wrong. It should just be direction. That's what it was. Old variable. Oh, I forgot. That should be moved so that its beast cam isn't blocking it. I keep forgetting to do that. Part 2 is way easier. Yeah, this is ending up being tricky. But a lot of it's because I'm just screwing up. They're gonna find it this time? We can cheat and look in this folder. It's still exploring the... Oh. 100 bits! Thank you, Crystal Coder. North, south, east, west. May your journey find you well on your coding quest. Nice. Alright, so... It's still exploring. Oh, it's stuck. It's not actually backtracking, is it? Okay, it's stuck. The robot's stuck. Okay, how did it get stuck? Actually, it's kind of hard for me to look at it in this window. What if I just use this window? How did it get stuck? It's stuck in this hallway, right? So then it backtracks. 1. Oh, when it backtracks, it adds to the trail. Oops. When it backtracks, we don't want it to push back onto the trail when it moves. So let's change the meaning of this one. Let's just change that to backtracking. And then I'll change this from a false to a true. And then we'll turn it off if we are not backtracking. And then we'll only push onto the trail if we're not backtracking. If not backtracking, push our direction onto the trail. Yeah, it was ping-ponging back and forth. All right, let's try it again. Less out. Let's see where it's going. Oh, did it find it? It found it. Found the oxygen system. Up here. There, it found it. Interesting. Okay. We should record our starting position somehow. If I can see that. Let's have it be a star. If position.x is 0. Wait a minute. It's if min_x plus position x equals 0. And min y. Actually, what am I doing? It should just be position x. And position y equals 0. Then color is 5. And I'm going to move this to the end. To there. Because I don't think we need to see it every step anymore. As much as it kind of looks cool, I don't think I need to see it. Because then I don't need to do the out, right? Well, it's still doing this crap. Maybe I can get rid of this machine 1 run needs input. Let's just get rid of that. I don't think I need it. Needs input and get rid of that. And what else? What other stuff we don't need? I guess that's it. We'll just see all the moves now. Backtracking. So there's our map. And I guess it's hard to see the star. Where is it? There it is. So there's where we started, way down there. And it eventually found a path there, but it didn't see a lot of the walls. Oh, so really we need to find the quickest way, though. You can't just find where it is. We should try to find our way back the quickest way, right? Hopefully get 64-bit before the 38. Oh, for time t? Because the time will will wrap around unless you put in special code to record the epic as a secondary int. Okay, we found the oxygen system. But we don't know the quickest way to get there. I guess what we should do is once we find the oxygen system, we should try to take the quickest way back that we can find. And we'll still have the backtracking in there. Actually, wait a minute. The track will bring us ultimately back, right? But it's going to be a roundabout way, maybe. Yeah, so we should try to find a direct path back by filling in. I think we should just do is have it continue until it can't explore anymore. And then we'll get a complete map, right? So instead of stopping when we find the oxygen system, we'll just have it continue going until it gets until it backtracks all the way back, right? And then it'll be back at the start, and then we can use pathfinding to find that. Right, I got it. So while we can still have that flag, but we'll have another one. Actually, let's just make it an infinite loop. That's the easiest. And then when the trail is empty and we're backtracking, then we can break at this point. Because we should have filled in the map at that point. Yeah, so now that should give me a complete map. Yeah, so it should be filling in all the walls. Oh, it didn't, though. It got stuck here. Why did it get stuck there? It didn't look here. Let me think about this. Oh yeah, Beastcam is live. Yeah, he rotates occasionally. And I won't even notice because he's so quiet. Sometimes he'll jump down and I won't even notice. Okay, so why did it get stuck? Let's put that to an output file. And then let me look at the output file. Oxygen. So we found the oxygen system. And this is the map. So when it's sitting there, it should backtrack a ways, right? Trail is, wow, 295. So it should go backtrack. And it is filling in walls on the way back. Okay, why did it find the oxygen system again? Let me see this. Hold on. Cats are vicious, cruel monsters. Don't let the cuteness fool you. Yeah, gotta beware. So we move to that position. So that's next, that's to the left. And then 1819, 1819, and then 1919, 1919, no. Wait, why did, it found two walls and then moved back to the right? Huh? Why did it move there? Okay, then something's messed up. Backtrack? Backtrack. Found a wall, found a wall. Oh no, it's still backtrack. Now why did it backtrack back to there though? That doesn't make sense. There's something wrong with the trail, I think. What is it though? Okay, when it went there originally, did it hit that spot twice? Okay, so 18, 19, 20, and then down... No, hold on. Wait, I found the oxygen system wasn't in a move? Oh, okay. We didn't print that. We should print that. That's why I'm confused, I think. And the same thing, we're not doing that. Yeah, that's probably how it's got screwed up. So there's a lot in common between case 1 and case 2. I actually think I will combine the two. Because most of the logic is the same, right? It's just we're doing an additional thing if we found the oxygen system. So if output is 2, then we found the oxygen system. These additional things in here. Right. Oh, no, there's also... Oh, did I misspell that? The two S's in there? No, the S is just in the wrong spot. Okay, so, that line should move there. This line should move... Oh, I had it wrong. That goes there, and that goes there. Okay. Let's flip it, because it looked better the other way. Okay, I'm going to settle with that one. There we go. Hey there, 715209. How are you doing? Mr. Destructoid indeed. Alright, let's see. We get a maze? Oh, we did get a maze. Look at that. Look at that nice maze. So, and it makes it all the way back to the starting point, right? Actually, we don't know. Because... No, yeah, robot mode to 0, 0. Okay, so it works. We got the maze plotted. So the final thing would be to do a pathfind, which I have the code for. I'm going to actually just use it. So, let me find that pathfinding code. It's in my game. Under, where was it? Realm server, source, pathfinding. Let's just pull in this whole file and put it into our main, because that's how we roll. We're just going to put it right on top here. It's a big template. And, oh, actually, it's more than I need. I just need the find path template. Right? No, this whole thing we need. Pathfinding template. There's extra stuff we don't need, like find reachable places, so I'm gonna get rid of that. We don't need find reachable places. Okay, so this template has a find path, and we give it a starting position, a destination, and we have to give it 3 functions. One that we use to tell it, you know, what are the neighboring positions, and a cost function and a heuristic. And we get back a path. And the path's, excuse me, the path's length is all it cares about in the problem, right? We just need to know the fewest number of movement commands, right? You're not feeling well today. I'm sorry. I hope you feel better. Hope you get better soon. My friend Ski Dog also was feeling bad yesterday. He said he was sick. Get better. Get well soon. Okay, so I'm just gonna try to use this thing. So, use the A-star algorithm to find the shortest path to the oxygen system. So that's find path. Is this within a namespace? Oh, it's within a template called pathfinding. Pathfinding, and it's position, right? Yeah, how is this T type used again? It's just passed to other things, right? Yeah, so we can make this position : find path. So we need a starting position. So that is 0, 0. And then we need a destination. Oh, we forgot to record where that was. Let's do that. So position oxygen system. When we find it, down here, we'll record where it was. Oh, did I have a check to see if we actually didn't find it? You know, it's always going to be in there, right? So maybe we just remove this flag. We don't really need it anymore. I originally needed it because I thought I needed it because we would stop once we found it, but we can't stop until we find all the walls first. Okay, so we don't need it. We have oxygen system as the target. And then here we need the neighbor function. So let's break this out into, let's just make some lambdas that call some functions for us. So we're going to use the cells by reference. And this needs a const position. And the code is return neighbors cells position. Okay, the next function is a movement cost function. So that doesn't really need a context at all. It has a position start, position. Actually, if it's no context, we can just provide it position cost. And then the heuristic. That also we don't need any. Oh wait a minute, no. The heuristic is the one that is generic. So position heuristic. The cost function, we do need the cells because we need to see if there are walls in the way, right? Const position start, const position end, return cost, cells start end. Actually, I don't think we care about the end. I mean the start. The end is whether it's a wall or not, right? And that's it, right? Thank you for that follow. Hey there, Aditi. Your browser closed by accident. Oh no! Now you're not feeling well, and you're closed your browser. It's just not your day. I'm sorry to hear this. Okay, so I need 3 things: a neighbors, cost, and position heuristic. Let's just call this. Let's do position heuristic first. That's the easy one, right? So the heuristic. What's it needed for again? I mean, what are its? Let's find path. The heuristic is a cost function, so it returns an int and is given 2 positions. Got it. Returns an int, it's given 2 positions. Start and end. So I'm just going to use a Manhattan distance for the heuristic. So return absolute value of... why did my cursor jump like that? Absolute value of end dot x minus absolute value... no, it's absolute value of end x minus start x, right? Plus the absolute value of end y minus start y. That's going to be our heuristic. Now I need the neighbors. The neighbors is easier, so let's do that next. Neighbors returns what? Neighbor function. It returns a vector of positions. Makes sense. So vector of positions. Neighbors to a position. And this, oh, why did it doesn't need cells. It can just be neighbors. Okay, and then I just need the cost. I need a comma there too. I need the cost function, which does depend on the cells. So cost function return, it's the same prototype as the others, except for I added another argument, right? I added the cells. That's what this lambda does. And the cells is this thing. So const that cells. One problem is this cell was defined inside the main, so I need to move that out. Let's put it at the top somewhere. After the pathfinding sounds good to me. So we'll put it here. All right, and then that will build, right? Oh, it only needed the end, not the start, so I can get rid of the start. So that should... it will build if I return something. Neighbors must be return a value also. Yes, so let's just return empty right now. I just want to make sure it compiles, and then I'll fill in the detail here. Okay, so once we get the path, const auto path, we just need to know how many steps, right? How do they phrase it? The fewest number of movement commands. The fewest number of movement commands required to move... let's just say the distance is the shortest distance. Shortest distance. Why am I even trying to make it a sentence? I don't know. Shortest distance is the path dot steps dot length or size. I guess there are other things in there. Oh, there's also a reachable and a cost. So it might not be possible to reach it. In our case, it will be. Actually, we could just use the cost, can't I? I don't even need to look at the size. Just print the cost. Okay, I just need to fill in the stuff now, right? So, neighbors is easy. It's just given a position, return its neighbors. So, position x minus 1, position y, and then 3 more, right? Plus 1, and then minus 1 here and plus 1 here. Those are the neighbors. The heuristic we already did. So the cost function. The cost functions just look up the cell. So const auto cells entry is cells find end. If cells entry is cells end, return, that means it couldn't be found. I don't know. What do we want to put here? 0. Else, if cell's entry second equals cell wall, then return some prohibitively expensive number. How does this work with find path? There's a max cost. So we just set it really high. Actually, I should know the maximum cost. I'll just pick an insanely high number. Actually, that's probably too many for an int. Thank you for that follow. Let's pick 1 trillion. No, 1 trillion is too big for an int. How about we'll be crafty. We'll include limits. Shoot. Where was I? There we were. Okay, we're gonna be crafty and return standard numeric limits of int max cost, right? Else, it'll be a floor or something else, right? Floor or oxygen system or unexplored. Those are all cost 1. So there we go. There's the cost, and we see that it is a huge negative number. Okay, that's not good. Why did we get that? Why is the... Oh, is it because I didn't initialize it or some stupid thing like that? I wonder if I ever tested that in the first place. This path, right? What's the default? No, that's the default is 0. How did it get to be a huge negative number? It's an int. Oh, it might be uninitialized if it's not reachable? Oh, it could also be because it's actually true. So I need to set a max cost here of standard numeric limits int max, so that it doesn't try to go over that. Actually, I wonder if I'll get in trouble with overflow here. Yeah, I think I'm getting trouble with overflow. So let's set a more realistic thing. How about 1 million? It'll never go over 1 million. Nope, I have something else that's broken. Let's debug it. It's like, instead of guessing, I should just be debugging. Thanks for that follow, by the way. 14 replace with 15, pick 15, and then we're going to go to the code down here. Go. So the oxygen system's at -16, -20, and I'm just going to step over it. What's the path look like? It's reachable. There are 220 steps, but the cost is all messed up. Why is the cost messed up? I'm wondering if it's passing over a wall. I bet it's passing over a wall because I was too crafty with that limit, numeric limits. I'll set this to 999,000. Actually, if I set the max cost to 1 million, I'll just set this to 1,000,001. Oh, did I close the output file? Why did I do that? 296. So yeah, not passing over a wall. Do I want to plot that on here somehow? That would be kind of cool, right? Thank you for that follow. Let's plot the shortest path on the map. So that means we'll move displaying it till after we've found the shortest path. And then we'll say, plot the shortest path. Oh, there's an easier way to do this, isn't there? I can take these... No, I can just take these steps. I can just introduce a new kind of cell, right? Unexplored. So we'll add another one. Oxygen system will add path. So that And then I had this for center. So path will have, how about an X? It's going to be hard to see these things. I'm not very good at picking symbols. What kind of magic is this? Magic numbers, yeah. Well, you have to put a bound on the algorithm somehow, and you don't want to overflow your integers, so let's see. I could go back and try to find why I couldn't use numeric limits. It's probably because in my template I'm not checking for overflow somewhere. Anyway, plot the shortest distance for const auto step, actually step in path dot steps. Cells step equals cell path. Done. Oh, I forgot it's a bunch of output first. Out. Okay, it's really hard to see that path. But yeah, it goes this way, and then around here, goes down, right, down, down here, up, left, up. Why is it using percents? I must have had off by 1 or something. It's to go up here, and then down, and then around, and then down here, up. Wow, it's a very convoluted path, isn't it? They made this maze hard. I guess it's to make sure that you do find the shortest path. So it's avoiding this whole area of the maze here because there's no other path in. This is all walled off, right? Yeah, it's all walled off here. That's why it couldn't go that way. And this must lead nowhere. So yeah, there's no way to shortcut that. Correct. Okay. Why is it printing percents though? Oh, because of that. So this goes here. I want to make it look nice though. X's don't look nice, and it's also overplotting the last spot, so let's not do that. If step is not equal to oxygen system. There. So there, we go from the, it's hard to see, this star to the end here. What about plus? And then question mark for unexplored? I can do this. We can do that. It's all a matter of these paints, right? And then you wanted plus for what? Position that we walk to? But white filled in character. I might have trouble with Windows code page if I try to use like weird Unicode characters. Although I guess if we look at it in VS Code, it should look okay. Anybody have some characters they want to see? It's still hard to tell the difference between a path followed and the wall unless I highlight one of them. Then it kind of colors it in, doesn't it? Maybe that's good enough for now. I'm kind of killing time right now. I shouldn't be killing time. Maybe use an emoji. Adam fails for the walls. Adam pass for the path to the exit. So let's fill in our answer. 296. That didn't work. 296. Yay, I got it. Okay. So that was an hour and 25 minutes. That was fun though. How come the file is closed? I closed it? Why did I do that? I want the, you can tell I was playing Minecraft a while ago. Where I put that file? I probably put it in this directory. Yes. I closed this for some reason. 15-1. And, oh, I had moved these close together because I was copying that into a Discord somewhere. All right, so this was an hour and 25 minutes. I got a gold star! Yay! Does the output look good? Or do we want to keep going? I could add 4 more dashes if I really cared. Or I could programmatically add as many dashes as it is width. Or I can just hack it. There, I hacked it. Because that's how I roll today. Now it's nice and dashed. So there are some unexplored parts. There are like unreachable places within the map. I know I have dark, cool glasses that are somewhat offset from where my eyes are. Way to go, Twitch. All right. 15-1 solution. All right, should I be dreading part 2? Let's move on to part 2. Resetting my timer and continue part 2. You quickly repair the oxygen system. Oxygen gradually fills the area. Oxygen starts in the location containing the repaired oxygen system. It takes 1 minute for oxygen to spread all over to all open locations that are adjacent to the location already contains oxygen. Diagonal locations are not adjacent. Suppose you use the droid to explore fully and have the following map. Oxygen is a big O. Initially, the only location which contains oxygen. Right after a minute, it spreads to those two. So it's a flood fill. Finally, whole thing. Use the repair droid to get a complete map of the area. How many minutes will it take to fill with oxygen? Oh, that's easy. We just did a pathfind with A-Star, and now they want me to do a flood fill? Thank you, TS Joss. You beat Rally Monkey to it, indeed. That's hilarious. Is there a way to solve 15-1 without using A-Star? Because, yeah, we just did a pathfind to find the shortest path. Now they want us to just do a simple flood fill. Okay, let's see how fast I can do this. Copy, paste that to 15-2, go to the... Oh, sorry, I copied the output. Remove that. Go to the source code, copy, paste. 15-2, make file. To there. To here and here. Build it. While it's building, let me get a jump start on this. So we're going to do the same things, and we'll even display this in here. And so the next thing we're doing is flood fill oxygen throughout the ship. So we'll introduce another kind of cell called oxygen. And we'll just replace the oxygen system with oxygen, right? And count the number of minutes it takes. So cells oxygen system equals cells oxygen, cell oxygen. And then we're going to have a frontier set. So it's a standard set. Do I have a set in here? I do not. So a set of positions, frontier, insert oxygen system, and then we'll have a while not frontier empty, and then we'll count the minutes. Can I use that? Will it let me do that? Oh, it will. I know what you meant. You meant to put it into the map, but I'm not going to bother plotting the flood fill because it's just ridiculously easy. But I am going to use that for the variable name because I can. That's hilarious. It is using UTF-8. All right, cool. So that's our wave, is the number of minutes. Okay. Or maybe the wave should be the frontier. Yeah. So the wave is a set of positions. It starts at the oxygen system. And then is it 1 minute per step? After 1 minute. Okay. So we're just going to look at everything in the wave. And we're going to form a new wave. Standard set position. Actually, we'll just swap. Auto next wave equals a wave. And at the end, we're doing a wave.swap next wave. All right, so for const auto, what's another emoji that would represent one tile of the wave? How about lightning bolt? Because why not? How about pizza? One pizza in all of the wave. And yeah, we're flooding it. It's not oxygen, it's pizzas. We're going to look at the neighbors and see if any of them are floors, basically, right? This won't be confusing at all. No, it won't be. We're flooding the ship with pizzas. I mean, obviously. I can use that nice convenient array I had of directions, right? If I move it out of the infinite loop, I can, along with its type definition. So I can just iterate the directions here. So for const auto, oh, I don't want to initialize this, do I? This is a decal type of that construct. There we go. What's that? What is that? A shower? I can use that instead of pizza. There we go. So this is direction in directions. We want to add the new direction. So const auto next shower equals shower plus direction dot delta, right? If, okay, so const auto cells entry is cells find next shower. If cells entry is, well, it'll always be in there, right? So I really don't even need to do a find. I can just say, I can just do a switch on, or I can just do an if. If cells equals cell, it'll always be, oh, wait a minute, I should clear out the path. I should not do the path thing anymore, because that'll screw it up. Well, no, I can do that. I can just say if it's floor or path. If it's a floor or a path, then we have to do two things, right? We need to fill it. Next shower equals cell oxygen, and then we need to put it into the next frontier. Next frontier insert next shower. I'm loving it. I'm gonna start using emotes everywhere now. Why emojis? Just to be fun, because we're doing a flood fill, so that's the flood. So every step of the flood, while the edge of the wave is not empty, we're forming a next edge, and for every a shower in the flood, we're looking at all four cardinal directions, getting that next position. If it's floor or path, then set it to oxygen, and then add that to the next frontier. And then we're going to swap that with the next and loop. And so we'll stop, and I need to add one to minutes, right? And we stop once it's empty, and then we print it took that many minutes to flood the ship with oxygen. That's not going to print correctly, but I don't care. So minutes. Let's try it out. Okay, what did it not like? I hope it's not the emojis it didn't like. Oh no! This character is not allowed to be an identifier. We can't use the flood thing. Tragic. Okay, can I use pizza? Let's see if I can use pizza. If I can't use pizza, I'll be sad. Oh no, I can't use that either. How come it allowed flood but not pizza? Should we use then, what is that character? I don't know what that is. Hey there, Resubaka. Oh, and I didn't say hi to Sai or Piano Boxer. I didn't notice Piano Boxer. Sorry. Where was Piano Boxer's chat? Hold on, let me find. Oh, there you are. Allow UTF-8 on the compiler with /UTF-8. Yeah, I don't want to. Let's just see if this one works. If not, I'll just give up on that emoji. Yeah, it doesn't like that emoji. So let's just replace it with Edge. And okay, I can't do a plus on positions. Why? Did I not add a plus operator for positions? I do. Why not? Oh, this should be const. That would make sense. Okay. Cool. It's interesting that it's okay with the flood, but it's not okay with pizza or a shower. Loving the beast cam. It was WinFace, but it looks like the chat client does not allow it. 100. It's weird that some emojis are allowed and some aren't with Microsoft. Anyway, let's run it. So I've got to go to 15.2. Copy the example. And then just pipe that to output and take a look at it. Took 303 minutes. $303. Submit. Uh-oh, it's too high. I messed up. All right. What'd I do wrong? I suppose we're gonna have to look at it one step at a time and see where I messed up. So that means printing this out again, right? Is the input different? I thought the input was the same. Same input. I just probably screwed up the minute counter. So let's do that after every minute. So I'll need something to represent the oxygen. So how about big O? And actually, there were two reserved ones, right? So that goes there, and these more magic numbers, sorry. It's too cocky, I think. Let's look at the output now. Okay, so... Oh, I think I see what the problem. After, that's at 0 minutes. This is after 1 minute. It's already spread. So I was off by 1. How did I get off by 1? Let me see, get this exact here. Okay, so initially it has oxygen immediately at 0. Got it. Okay, so I'm off by 1. We actually have to put it in the frontier and not fill it. No, I can't do that. So I just need to start it at -1 then. No, start it at 1. No, hold on. No, it's correct, isn't it? After 1 minute, it'll be 2 adjacent, so it is correct. The info for this task is so weird. So what did I do wrong? If this is at 0, well, it's not showing. It's showing it as an oxygen generator, and then after 1 minute, 2 minutes, 3, 4, 5. It said it doesn't spread diagonally, right? 6, 7, 8, 9, 10, 11, 12. It's at the intersection now. 13, so it's spread both ways. 14, 15. Yeah, what am I doing wrong here? I guess I could print it. Here. After that many minutes. There we go. Imagine only having the original cell reachable. You always had 1 in the loop, so you get 1 without any fill passes. But they said after 1 minute, you have it in the original plus the 2 adjacents. After 2 minutes, it's gone 2 steps away. I think my count is okay, unless I'm not understanding this. But joink. After 1 minute, so it's the original spot plus 1. It's gone 1. So at the end, it's after 303. 302, it hasn't yet reached the 0, 0 square. Well, but I started at 1. Well, this is 0, right? At 0 minutes, this is filled. After 1 minute, it's 1 adjacent. So how could I be off by 1? After 2 minutes, it's 3 filled, right? But I end up counting the 1 time it loops. All right, so how am I doing this wrong? This is at time 0, right? And at time 1 plus 1 minute, it's that plus 1 square. So, and it continues to the after 203, it's filled everything except for that origin. So 301, it's, oh, wait a minute, it plotted the same thing twice? No, it's way down here. It had to fill that one in. Yeah, there's a corridor down here which was the last to fill, and there's some other corridors here that didn't fill to the end. Oh, wait a minute. No, you're right. That was the last one to fill. Yeah, okay. Summer Breeze had it. I counted the last one twice. So let me give you a useless internet point. So it's when it's completely filled, it still loops back and tries to fill it 1 more time. So really, we only want to add 1 to the minutes if this is not empty. Or really, we can just say if it's empty, then so we can move the minutes. It's problematic. I just say if it's not empty, don't advance. Actually, I should just break out here. So why don't I just make this an infinite loop? And if we couldn't spread it, if it's empty, break here. Otherwise, 1 minute passes and then we, yeah, okay, that makes more sense to me. I should probably comment that to say why I did that. 302. Okay, so let me comment that for myself or anyone else. So advance the frontier 1 more step. If we could not advance the frontier, then it means we've filled the entire ship. Nope, not that other word. Filled the entire ship. So we're done. We were done. We were done already. We're still filling the ship with oxygen, so advance time 1 minute at this point, and then display it, and then there we go. Which day is this? This is day 15, part 2. So catching up. So right above my head there, it says what I'm working on, as long as I keep it up to date. So I was off by 1, so that caused me to make this take a little bit longer. So that was, I'm going to round it up to an even 19 minutes. That's how long it took me. The first part was hard. The second part was Should have been easy, but I messed up a few times. 19 minutes. Let's check it in. Blup, 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 blup. Let me take this comment from the last commit and just reuse it and put a 2 there. Okay, now we're almost caught up, right? Because there's only 2 more days and then we have to wait 9 hours. Now, how am I doing on time? I have another 2 hours I can do this. Let's see. Current tasks. We're going to do 16-1. The beast is still asleep. Good thing, because the beast wakes up, I got to fear for my safety. He's liable to claw my face. He's like jump down from his tower onto my head and I'll be like, ah! Alright, so. Sorry, I just felt like being wacky there. Excuse me. 16-1, start the clock. Flawed frequency transmission. You're 3/4 of the way through the gas giants. Not only do round-trip signals to Earth take 5 hours, but the signal quality is quite bad as well. To clean up the signal with the flawed frequency transmission, FFT, like fast Fourier transform, is this what we're talking about? As input, the FFT takes a list of numbers in the signal you received. Each number is a single digit. Data like 15243 represents the sequence 15243. Got it. It operates in 2 phases. In each phase, a new list is constructed with the same list as the input list. This new list is also used as the input for the next phase. Hold on, I didn't get that. In each phase, a new list is constructed with the same length. This new list is also used as the input for the next phase. Okay, so, right. So the output, are we using an encode computer? No. So it's a set that is the output of every phase is the input to the next phase, I think. Each element in the new list is built by multiplying every value in the input list by a value in a repeating pattern and then adding up the results. So if the input list were 98765 and the pattern for a given element were 1, 2, 3, the result would be 9 plus 1 plus 8 times 2 plus 7 times 3 plus 6 plus 1. Oh, I see. So this is really doing convolution with a sinusoid. So it really is doing an FFT, right? Then only the ones digit is kept. 38 becomes 8. Oh, that's interesting. They're just taking the modulus. While each element in the output array uses all the same input array elements, the actual repeating pattern to use depends on which output element is being calculated. Right, because it's the different frequencies. Of course, the base pattern is 0, 1, 0, negative 1, because it's a sinusoid of the highest frequency. Then repeat. So why would it be highest frequency first? That's weird. That's backwards. Then repeat each value in the pattern a number of times equal to the position of the output list being considered right. So repeat once for the first element, twice for the second. So the third, the repeating values would be 0, 0, 0, 1, 1, 1, 0, 0, 0, negative 1, negative 1, negative 1. Got it. While applying the pattern, skip the very first value exactly once. In other words, offset the whole pattern left by 1. So for the second element, the actual pattern would be 0. Oh, I see. Yeah, because we want to start at, this would be a cosine, right? So where it's going, it starts at, no, a sine. Starts at 0 and goes up first. This is a sine function. After using this process to calculate each element of the output list, the phase is complete and the output list of this phase is used as the new input list for the next phase. Given the input signal 1, 2, 3, 4, 5, 6, 7, 8, below are 4 phases of the FFT. Within each phase, each output digit is calculated on a single line, with the result at the far right. So yeah, it's 1. Right, where it's convolution, right? So the high frequency, the next highest, the third highest, the fourth. Got it. And so we're ending up taking the ones digits. That's 1 minus 3 is negative 2, plus 5 is 3, minus 7 is negative 4, so it's a 4. Got it. And then that is the input to the next phase, and we're just doing it over and over again. Why are we doing it? Why are we repeating it over and over again? That's the part I don't get. Is that just to iterate? Make it take longer? Here are the first 8 digits of the final output after 100 phases for some larger inputs. After 100 phases of FT, what are the first 8 digits in the final? Okay, so it's just a raw calculation. So let's just start with an empty program. Doesn't matter which, so let's just grab 15.2 and call it 16.1. Did I update the current task? I did. 16.1. One. Got it. All right. And then here, let's just clear out everything. Oh, interesting. I ended up copying. Ended up copying the file header. Let me fix that. That shouldn't appear anywhere here. And the pragma once shouldn't either. We probably need that other stuff though. Do I need Q? I do have Q. And vector's already there. All right, so clean that up. And the same thing here, right? Q goes there and everything else is deleted. Make sure that that actually still builds. Nope, I messed up something. Set is missing. Set in both places. Let me check that in as a little miscellaneous fix. So, these two. So, clean up extra lines copy pasted. All right, on to 16.1. So we'll just delete all this stuff. In fact, let's make it completely clean. Why not? Except for that thing which I like. It's that this is pulling in some stuff for memory leak detection, which I probably don't need, but I like having it, so why not just keep it? So delete everything but the main and this stuff. And we're gonna want standard IO, of course, and standard lib. Clean empty program. That only took me 6 minutes 50 seconds. Actually, most of it was reading. All right, and let me get my input. Get my input. There's my input. Example input is that. So copy the example input. Actually, I'm gonna overwrite that anyway with the shorter example just to test with. So let me steal from here the code that's reading a line of input. This stuff. Open the input file. It's just one line, right? Yeah, it's one line of numbers. Open the input file and read in the input digits. And we'll go ahead and just have a vector of it digits. Okay, IF stream and string. String and F stream are needed. And I'm going to need vector very shortly, so I might as well put it here. Vector. All right, so we have vector int digits, and we'll just say for auto char or ch in line digits. Actually, we can say digits dot reserve line length. Digits push back. We're going to want to just take the character and subtract the 0 character and convert that to int, right? Or the difference between the character and the 0 character. Push, push. You caught me. You got me. All right, so we got the digits open. Close that. And it's there's a phase count, so I can just have that be a constant and just print out every phase, and then we can just verify with the test example. So apply the FFT many times, and so const x per iterations, this is a size t, is 100 for size t I 0 I is less than iterations plus I. Why the explicit cast to int? Just because I'm being picky, because this is a char, and that's also a char. And I don't know if you subtract them if you get an int or if you get a char again. It's hard for me to see. What if I just say auto that? Auto digit equals that. What is the type of digit now? Oh, it is an integer. Okay, I didn't know that. I thought that when you subtracted 2 characters, you get a character. But it looks like you actually get an int, so I can just leave it at that, right? Thank you, Nui. I learned something today. At least, according to Microsoft's compiler, the type of that is int, not character. All right, we're doing this multiple times, and each time I have to remember the input memory and basically iterating it many times. Thank you for the follow there. Yo, Lupo, we're doing Advent of Code. It's sort of a series of programming / problem solving challenges, 2 per day, and I'm trying to catch up. Since it's the 17th of December for me, puzzle 17 is unlocked, and I've almost caught up. So I started real-time day 13, I started on day 1, and I've caught up now. I'm on day 16, and it's day 17 today, so almost caught up to real-time. Puzzle 16 looks like a frequency domain analysis, and just in tongue-in-cheek, they call FFT the flawed frequency transmission algorithm. It's really fast Fourier transform. So we're doing a bit of convolution here with some weird modulo math. So I guess that's to make it easy to enter the answer. You need to know a lot of math to participate. Some of them, yeah. So some of them I think you have really struggled with unless you knew some math. Like the last one I did required some pathfinding and flood fill. And so that's not exactly math, but I would say more algorithms. You need to know a lot of you need to know some basic algorithms, or else it's going to be really difficult. But there's one challenge where you have to figure out, like, there's a laser that's rotating in a circle, destroying asteroids, and it wants you to figure out which asteroid is the 200th asteroid that's destroyed. And for that, you had to sort of know enough math, like trigonometry, to figure out angles relative to positions in a grid. So if you didn't know basic trig, you didn't know how to compute angles from coordinates, then it would be really tough, I think. You started the Top Coder Marathon contest today? Nice. I am not a top coder or a marathon coder or a speed coder. I just have fun doing this stuff. And I'm showing how I would do it in C++. There are other streamers out there doing this in Python and other languages too. I knew math through calculus and differential equations, and I forgot most of it because most of the programming I do implementing stuff is just say, here is the algorithm. Someone's already devised it. Just implement it. Just get it to work. And you don't need to know a whole lot of math for that. You just basically following a recipe. C is king. I would say that a lot of people do believe that. I forgot. I should wave to you guys. Hey there, Dr. Cashews. And Summer. Hi. And worship the sofa. You worship a sofa? Interesting. Oh, and Chris is here? Where did Chris chat? I missed it. Emojis in code. You know what else is fun? Drama Sans. You loving the Beast Cam? That was back at 11:30. I'm sorry, Chris. I didn't notice it was you. By the way, you guys notice the overlay above my head that's showing the chat? It was actually developed by CM Griffin, who's in chat right now, I think, still, unless he's left. But he develops that live on his stream. You should check it out. All right. I'm going to want to hold some memory, right? Actually, I really don't need to. I just need to know the output based off of the input. So we know the output. That's this. So let's actually get that. Const auto. Let's call it something nifty, like order. Order. Reserve order. Okay, and so we're going to have another vector in here. Vector. Actually, why don't I just be really over smart and just do decal type digits and call it new digits. And then new digits reserve order. And then we're doing this how many times? Is the input signal, that is the input. How many phases do I do? Oh, is the number of phases the length of the input signal? Where does it say that? Let me make sure I understand that correctly. Repeating pattern. Yeah, I'm doing Advent of Code, yes. Indeed. There's a link to Advent of Code. Oh, I need to update that command because I'm not on 7. I'm not on 11. Edit com AOC. I am on day 16. I beat you to it, TS Just. Like by half a second. All right. Thank you. I'll give you a point anyway. Let's see. Only the ones digit is kept. No, what? How do I know the repeating pattern length? Used to Tim typing slowly. One. Oh, it's a square, right? If the input here is 8, then it's 8 lines. 1, 2, 3, 4, 5, 6. Yeah, okay. So it's the same number. So it's for size t. J is 0. J is. Let me think about this. I is the iterations. J is the order. Plus plus J, and then right. So we have to start at 0 and oscillate. How do I cheat so well? You're 107th on the leaderboard. Nice. So you'll show up on the board if you just climb 7 more spaces. Did he practice on stream? I should probably do some practicing. I get dyslexic on the keyboard if I just keep sloppy. Had to make your own script to calculate rank because it only shows the top 100. Oh, I see. Yeah, you're right. It doesn't show that in the leaderboard personal stats. Oh yeah, you're right. It doesn't show the overall rank based off of your points. I have 0 points because I'm so far behind. Go back to 15 part 2. No, I'm not on 15. What am I doing? I'm on 16. All right, so every line, okay, there's a third loop inside here, right? So it's a K order. And here we need to have a pattern ready. I guess we can compute the repeating patterns. Compute these sine waves used in the FFT. So we'll have another square, right? So vector of vectors of ints sine and one of these outside here to pre-compute it for us. So, we can reserve that in ahead of time. And then make another one in here. Wave. Wave reserve order. And this is the tricky part. The first one is... Okay. Why would it start with one and the others... Oh, we just back up one. Got it. So there's going to be a phase that starts at 1. So, const auto phase is K is J. No, it's 1. Or no, well, it's just K plus 1. And then, J is the row we're on. So that's the number of times it repeats. So J plus 1 is the period that we have to elapse before we... Okay, so, gosh, this is hard. It wraps around in 4, right? 1, 2, 3, 4, 1, 2, 3. Okay, so it'll be, that... Shoot, this is hard. This is hard to think of. I'm not a math guy. I need to multiply by J. So, does anyone know C language from here? You got a vector with 30 elements, how do you make a minimum of it? You loop through and you find the lowest one. Each one you look at, you see, is it lower than the previous lowest one? Why do you hate your life now with 50% more programming? I take it that you're in a class where you're learning C, and this is your homework assignment. So when you want to find the lowest or highest or any kind of criteria that you can compare or put in order, generally you start out with you take the first one, you say, well, let's just hope that the first one is the lowest. Then you loop through, you look at the second, the third, the fourth, all the way to the end, and for each one you compare, is this one lower than what we think of currently as the lowest? If so, you replace the lowest with that one and continue. By the time you get to the end, you get the lowest. Another way to do it is you sort the whole list, and then the first one is going to be the lowest. So either way, that's the general technique. Yeah, you got to fight through it. Yep. And at the end of the fight, if you look back on the past and you say that sucked, then probably programming isn't for you. But if you look back in the past and thought, yeah, it was pretty challenging, I kind of had fun, and in the end I learned something, then maybe programming is in your future. How do you use header file? You don't use header files to call variables. Header files are for pulling in the definitions of library functions and constants and other things. These are what header files are for, to include them into your program. To call variables, call either means to call a function, like getLine, we're calling a function here, or you could, if you use the word call, you could be saying what to call it, so what name to apply to it. But all these things are independent of header files. Use a header to include. It's pound include, and it's a preprocessor instruction. I'm doing my own stuff right now, so I don't have a whole lot of time. But if you have if someone in chat wants to, you could feel free to post a link in chat to if you have it in Pastebin. I won't have time to look at it right now. I'm actually on the clock. Try to see what my time is for this problem. But other people in chat are welcome to help out. Okay, I need to get this computed. Yeah, if you have a link to Pastebin or whatever, then or a gist or something, that's cool. I need to stretch this out, right? I need to take the index. I know what I need to do. I need to take the index and divide by j. So I need to take k and divide by j. So, no, j plus 1. Signatures of functions other people have written or yours. Oh, you're answering that. Okay. So if j is 0, we're dividing by 1. So it'd be 0, 1, 2, 3. So then I really just want to do, can I just have a primitive? So int primitive sign 4 equals 0, 1, 0, negative 1. And then I can say here that I think this is the trick here. I need to actually add 1 to that. And then take this whole thing and mod it by 4, and that gives me the actual number in there, right? So let me think about this. So it'd be 1 divided by 1. That goes here. That's 1 mod 4 is 1, so that will pull out this one. And then if k goes to 1, it'll be 2 divided by 1, so it'll be 2. So 1, 2, 3, 0, 1, 2, so that works. And then if j is 1, it'll be divided by 2. So 1 divided by 2 is 0. 2 divided by 2 is 1. 3 divided by 2 is 1. 4 divided by 2 is 2. So that works. So that phase gives me an index into primitive sign. And that's what I'm going to multiply by... Actually, that's what I'm just going to store into the sine wave, right? So wave.push back primitive sign phase. And then we're going to apply that. So to apply it, we're going to take... We're summing together, right? So let's make the sum here, right? Sum 0. Sum plus equals, we're taking the input digit. Where is the input digit? It's just digits. Digits k times sine j, no, jk, right? And then when we get to the end, we're pushing, so we're doing new digits, push back sum mod 10. I think that's right. Oh, did the cat jump down? Yeah. He went somewhere else. Goodbye, beast. Goodbye for now. He went into another dimension. Oh, hey there, Mr. Balrog. And Moose. And Crop. I didn't see your chat, but it's in there somewheres. Let me find it. Oh, you said had to make your own script to calculate your rank. Oh, right, we were talking about that. I just forgot to wave. Hi. All right. Did I do this right? So at the end, we're getting the new digits, and we're going to just basically swap digits with the new digits, right? And at the end, what does it want at the end? Does it just want the output? Right, so just print them out. So, actually, let's just display it here. Printf after n phases, and then we're going to just print them out, right? So for auto digit in digits, printf %d digit, and then at the end printf New line. All right, let's fix stuff. Printf is missing the I. Cool. All right, so let's run it. Heaven a code. It crashes. Nice. So when it crashes, I usually just like to prefer to run it in the debugger and see where it crashed. So comma, and then that 15 goes to 16. Pick 16.1 and go. See where it crashes. All right, so what is K? K is 0, J is 0, and K is 0. What is sign? Oh, sign was never pushed? Oh, I didn't push the wave into sign. Forgot to do that. Sign, push, back, standard move, wave. There we go. Hey there, Ramy. Wowee, look who's here. It's a Ramy. Let's see if... Oh, Ramy helped out. There's a dash in there because they're negative. We need to remove the sign, don't we? So it's push back the absolute value of some mod 10. Evan code, it's going. So, it took me almost an hour and a half to do 15.1. 15.1, what was 15.1 again? I've already blocked it out of my memory. Oh, it was doing maze walking, and it took me a while because I ended up having to do 3 different things. Explore a maze, then do pathfinding in that maze, then do a flood fill in that maze. So it just took a while. And then 15 part 2 should have been really easy, and it did only take me 19 minutes. It should have taken me less time, but I screwed up with off by 1 error. Still haven't done 3.2. 3.2 shouldn't be too bad. I did in 15 minutes. If I can do it in 15 minutes, you can do it in 15 minutes, I'm sure. Background doesn't change. Oh, I didn't update the current task, did I? Oh, no, I did. I did. Just getting confused. It is changing a little bit. So when I was at the beginning, it wasn't showing these planets. As I'm completing them, it's showing the planets. So this is Jupiter, that's Saturn. I think this is the outer gas giants. Uranus, Neptune, and all that stuff. So it doesn't show that until you get there. That's what it's adding. Just computing the answer through one literally took 10 minutes. I forget what was 3.1 about. Let's look. 3.1. Oh, I did it with sets, I think. I turned a vector into a set. A vector of sets. And I just did counting intersections and stuff, so it doesn't actually take that long to run. It always depends on the solution you go with. 16 minutes? Half a second, yeah. With a hash map, it's going to be really quick. Trying to raise and compare would be slow, yeah. Oh, okay. I had built that and I was going to run it and make sure that all the negatives are missing. Okay, so that's the actual solution. One problem, no, it won't be a problem. 100 phases shouldn't be a big deal. Just to make sure it works, I'm going to take the example that they have, the shorter example, and try it out. So 1, 2, 3, 4, 5, 6, 7, 8. Hash map took 16 minutes. So you optimize something about it, and then it took half a second. So what PHP's hash map is slow by default for that problem. So this is the shorter sequence, then we're going to run this, and we'll see if we get the same thing out. So after 1 phase, it's correct. After 2 phases, that works. And after 3, after 4, okay, no, we're wrong here. Oh, wait a minute, I'm off by 1. This is 1 phase, and I'm counting wrong. Counting wrong. After, this should say I'm after that +1. Now this should line up. Sanity check. So after 4 phases, it's that. Looks good. So, okay, so let's try the longer ones. And that says 2, 4, 1, 7, 6, 1, 7, 6. But why do they stop? Oh, just the first 8 digits. Okay. So let me try all of them just because you never know. I might have a bug somewhere. These you can think of as test vectors, right? That matched. Oops. Pin there. Okay. 5, 2, 4, 3, 2. Okay, so we're good. So I'm going to copy the actual input over and just run it. And here it goes. I got to wait for it to do 100 iterations of my FFT. You haven't found the motivation to continue it? That's where I got stuck. I think it was on day 2. I kind of got stuck because I was trying to optimize it, and really I should have just moved on. I thought, oh, this is sort of brute force, so I should try to optimize it. And I think it's kind of a trap sometimes. The game isn't really about finding the most optimal solution. It's just trying to find a solution fastest, or find a solution. Unless it's part of a personal achievement or goal for you to try to get the most optimal. But then I would stop once it becomes demotivating. Yeah. Don't give hints? Okay. No spoilers? I'll try not to. I just, in general, some of these puzzles you can brute force and just take longer. Some you can't brute force because it would take, like, millions of years. Yeah, that would be helpful. No one give spoilers in chat. Need to reverse the polarity of the neutron flow. Come on, no hints, TS Joss. Okay, this is done. It wants the entire string? No, it just wants the first 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. Submit. Yay, I got a gold star. Yay. I got a gold star. Hold on. I need to do get log -2 because that string I want. I wants it for here. 16:1. That's my solution, and it took me 36 minutes 46 seconds. I'm gonna round up to 37 minutes. Get push. 16:1. You know, we're not recording these end times anymore. Let's just remove these, and we'll just shorten these. Zoop. There we go. So this one was 37 minutes. Did you just copy a string, paste it into the other, and open the commit GUI, copy the... Yeah, I did. Yeah, that's how messed up I am with my development flow. Yep. Sorry. Part 2. Start the timer. Now that your FFT was working, you can decode the real signal. The real signal is your puzzle input repeated 10,000 times. Wow. Yeah, thank you, TS Just. I'll never remember to do this myself. I'm so dependent on you guys. Come on, editor window selector. There we go. I got too many windows open. Can I just close them all? I don't need this. Close them all. Point Farmer 2020, exactly. Do you delete obsolete code or just leave it in? I'm leaving a lot of it in for the admin of code, so I'm doing a lot of copy paste from one solution to the other. So like a lot of these build on the previous ones, but I keep the old ones there anyway. I didn't really need to do that, but it doesn't take that much space. These are all just a single main CVP, usually like less than 500 lines, so it's all cool. So this is going to be based on the 16.1. So let's just take 16.1 and call it 16.2 in a copy. Yeah, that's right. I have Git, but then it's kind of nice to have them all laid out. So I can go back and look at the code for a previous solution without having to go to Git. You know, I've done that a few times, right? Said, oh, what's that asteroid one? What did that look like? And then it's there. I don't need to go into Git to see it. Oh, I wanted to take your guys' solutions and check them out, because day 2 attempt to... Is that part 2? Day 2 is hard for me, so I wanted to look back at what other people did. Did I already have one for you for... I have Endurn, TS Jost, so this will be Endurn's day 2. And you're saying lol. I hope that means that you're happy about it. Oh, attempt 2 at sharing the code. All right. So it's not your second attempt to solve it. It was your second attempt to share the code. All right, so I think we're going to get in trouble because it wants me to repeat it 10,000 times. Treat this new signal as a single input list. Patterns are still calculated as before, and 100 phases of FFT are still applied. The first 7 digits of your initial input signal also represent the message offset. The message offset is the location of the 8-digit message in the final output list. Huh. Spin is only for up to 24 hours. Was day 1 really just advertisement or someone's web service? I don't know. But day 1 was pretty... Day 1 part 1 is really easy. I remember that. In a sense, the Evina code does have advertisements. They have advertisements here and there. But I think it's just because it costs them time and money to do it. So they're trying to offset that. It's just ads like any other site. Location of the 8-digit message in the final output. The message offset indicates the number of digits to skip, right, before reading the 8-digit message. For example, if the first 7 digits are 1 through 7, the 8-digit message would be the 8 digits after skipping 1,000,000 digits of the final output list. Or if the message offset were 7, it would be skip those first 7, so it's this 8-digit number, right? Of course, your real message offset will be a 7-digit number, not a 1-digit number like 7. Because it's really dang long, right? Is the output... Yeah, the puzzle input hasn't changed. How long is it? It's 651 digits. Wait a minute. But this is a long number. I don't get it then. Oh, the input itself is repeated 10,000 times. I get it. So it's 10,000 times 651. Got it. Equals? Val. Then I had a shortcut to do this. Eval. There we go. That. Eval. That one. 6,510,000 lines long. Wow. So this is going to be crazy. I don't know if I'll be able to do this one. This is going to require some math because it was slow enough before. Wish you knew more math algorithms. Yeah, me too, Dr. Cashews. I feel the same way. I was really struggling with some of these because they require some math that I had forgotten a lot of it. Like yesterday I got stuck on finding the least common multiple. And like, how do I do that again? I had to look it up. Yeah, okay, how are we going to do this? I guess I'm supposed to recognize some pattern. So let me go and look at the last one's output and see if I see some kind of pattern in there. Oh, I didn't pipe it to the output. So let's do that. Hmm. Is it also 100 times? No, it's 10,000 times. No, it's still 100 phases. Okay. Are you guys still talking about puzzle number 2? Okay. Int code. Yeah, I had fun with I like the int code computer. It's a virtual machine. Okay, I'm gonna try to make sense. I'm gonna try to make sense out of what's happening here. I should probably put the original number in here. That's this number. Input is here. Can I take a look at this? Maybe I'll gain some insight here. It's essentially giving us like the frequency domain of the input, right? But then it's applying it in it's iterative. And it's giving us the least significant digit, so it's really just scrambling the thing, isn't it? Looking at the example on day 16, part 1. Yeah, that's what I was looking at. So this reminds me of how the trick that they did for which one was it? The one that took me a long time. All right, I need to find that file again. Open recent. I should have that open too. The times, right? This one, 12.2. 12.2 threw me for a loop because they had something that you could do brute force, but then part 2 was like insane. They're like, do this like 15-digit number of times. And the trick to this was to break down the problem into smaller problems that you could solve. Oh, sorry, spoilers. I'll try not to spoil it too much. If it's something that can't be brute forced, one technique is to try to break the problem into smaller problems that you can brute force, and maybe that's what I need to do here. So there's a lot of repetition here. Can I break it up and do things separately? Actually, I think I know how to do that. I can just look at the first 8 rows, first 8 columns, right? Does it even matter? I don't need to go more than 8, right? Because it only... Hold on, let me think about this. Oh, wait. For the last one, I do have to do it. Shoot, that's a problem. Because of this offset. I was like, can I just do the first 8 columns and just trash the other columns? Because the columns, later columns aren't needed for the previous columns. But if I need the nth row and it has an offset into it, it's going to be basically the bottom right of this huge square. Later columns are needed for previous ones? Are you sure? Oh yeah, you're right, because this would... So if I consider, like, if I only needed the first 2, I still need all of the columns. Okay, so I can't get away from that. Okay, so that's a problem, isn't it? But I wonder if the hint is that if I know the offset right away, then I really only care about those columns and nothing before it. So can I skip the earlier columns? Wait a minute, I can, right? Can't I skip all of the earlier columns and just look at the column that I care about? Let me think about this. So if I only, let's say I only cared about column 7. Let's say I only care about this digit here, this 5, right? Then I really only care about the 7th row. Let me think about this. I will need all the columns. Of the previous phase. I'll need all the columns of the previous phase. Shoot. I wonder if I can reduce the number of nested loops here somehow. Like, can these phases be folded together? Where is that 4 used? It's used for this entire row. What I just realized took you an hour? Well, I'm kind of grasping here. I don't even know if I'm getting things. I don't feel smart. I still don't see a way to like reduce the number of computations that we're doing. Unless maybe the fact that there's only 4 different possibilities here. Oh, wait a minute. We can throw away a lot of the zeros, right? We can throw away half of the calculations just by knowing that it's times 0, then we don't care. So there's going to be a big swath of 1s, there's going to be a whole bunch of stripes of 1s and negative 1s in there, right? Okay, maybe I'm getting somewhere there. So for like an enormous square, there's going to be a lot of 0. Half of them are going to be 0. I can reduce it by half, right? I can just not do the multiply in certain phases. Let me just see if I can cut down on... Let's just run it. It's built, right? Did it not have any input? Doesn't have any input, so copy the input. So I have a feeling for how long it takes, right? Now let's see if I can cut it down. Thing is, I closed all my files. How much time do I have? Another hour and 15 minutes? If we know that that's a 0, I can remove the multiply, right? And the add. So const auto arg is sign. We're still doing a lookup, which I hate. I wonder if I could do it with math here, because we pre-computed it up here. We'll at least have to do, well, what's more expensive, a lookup or a modulo? And with 2 adds and a divide, I don't know. This might not matter at all. We can say if arg is not equal to 0, do that, and then that's arg here. This probably is not significant at all, right? No, it doesn't seem to be any faster. Okay. How do I break this up into smaller problems? Let's pretend that this is the huge area, and right now we're only like getting a 2x2 area. How would I avoid all the areas I don't care about if I just needed this bottom quadrant? Actually, it would be this bottom, it would be sum of the rows. Mod 4 is like and 3. Yes, exactly. I think the compiler will actually end up optimizing it to that anyway. I have a feeling the trick here is to recognize that this is doing frequency domain analysis, and that if we only care about very low frequencies, does that mean I can just discard these upper frequencies completely? I don't know. But the fact that we're doing it multiple times, I don't get that. I don't know what to do. I think I'm kind of stuck. Shoot. Check whether your input is compared to the length of the signal. I saw that. It was, where was it again? This number, I need that out of the total message length, which was, 651, that, right? So this is the length, and this is the offset. So it's like pretty much in the bottom right corner. So I know that that's the problem here. I can't just like stop early. I can stop after I get no, I have to get down to that row. No, the row is 10,000. Row 10,000. Columns to 597,738 plus 8 is minus 1 of, yeah. It's expensive to compute a row, so that's going to be very bad. And yeah, I have to at least calculate this many columns. I don't know, it's very intimidating. I think. What am I missing? This is no longer a coding stream. It's a non-math person struggling with math. That's what I feel like. Quick math. Yeah, quick math. One plus one is 3, exactly. Can I gain any insight by looking at that column? No. Hold on. It's the input repeated. I wonder if there's something about that repetition that I can leverage. So it's if this is repeated, if this block is repeated again, what would it mean? Oh, wait a second. That will just be multiplied by the number of, this will just be multiplied by 10,000, won't it? And then it'll be 0? Because it'll be 40,000? Yeah. Okay, so every time... Oh, wait a minute, is that right? Hold on, what's the input length? It's 561. So input is 561 times 10,000, right? What's 10,000? That's 10,000. So it's repeating So I could compute it just for that, which I've done here, and just multiply that number by 10,000. Wait a minute, won't it all be zeros? Did it count a new? Did you count a new line? Maybe I did. Is that a trick? That might be something. Column 1. Yeah, it's only 650, right? If that's... What am I doing? I should just do word count. That ends in a new line, doesn't it? Shoot. I'll put the new line back. Yeah, so it's 650, so I'm off by 1. But hold on. If it's repeating 10,000 times, why won't they all be zeros then? It'll be whatever number it was. Oh, wait a minute. No, it's not multiplied. Is it? Those are some large numbers, yeah. I think I'm on the right track here because we know it's repeating. There are two things repeating. These numbers end up repeating after 650 times. These numbers repeat depending on the row that we're on. I guess it depends on if it's in phase or not. So the frequency of each one matters. So let's see if I can work this out. So the frequency of the first row is 4, obviously. One, two, three, four, five, six. Yeah, so it's 8, and it's n. It's if n and the frequency it's 1, 2, 3 is 12, so it's 4 times n. So it repeats every 4. So yeah, I think this is a key number. What are the factors of 650? 650 is well, 2 would go into a 325 2 times. So that's what am I doing? I should just use an online tool for this. Hold on. Prime factors. I did this yesterday. Prime factor calculator. Calculate. It's 2, 5, 5, and 13. Oh, wait a minute. There were some exponents in there. No, it's just 2, 5, 5, and 13. Yeah. Yeah, exactly. So let me think about this. Where does that intersect 4? You had 500. Right, you had 500. I have 650. And what is 10,000? Well, hold on. I'm trying to see if can I calculate just one block of 650 and then just skip all the blocks in the middle. Or I don't know how to explain this. Because I don't really care about any of the columns except for these columns. I only care about that row. I think I have to accept the fact that I'm going to be calculating all the rows, but at least maybe I can skip all the most of the columns until I get into the block of 650 that lies in there and figure out where it is. But I need to know how to skip columns if I can. If I know the repeating pattern. If this were to repeat again, it would be plus another 4, right? And then that would give you an 8. If it's repeating 10,000 times, that's the thing. If this is repeating 10,000 times, won't they all be 0 at the end? They'll be 0 at the end, but not in the midst of it, right? Let me test something. Let me test a theory here that I have. Let's take that short example, right? Didn't put it in the right place. Yeah, let's undo that. I need to go to the build directory. Input. Okay, so what if I were to repeat that 10 times? 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there is something interesting. They all end in 8. Actually, before they all ended in 8. And what's the digit at offset 4? 0, 1, 2, 3, 4. Okay, that... Why do they end in 8? And mine ended in 4. Okay, there's a hint there, I think. It's hard to see these side by side. Okay, that is a 0. That is a 0, but the second one is not a 0 because the second one is a different frequency, right? Oh, because this, the pattern didn't start over. And 0. No, it wouldn't. Yeah, it is a 2 zeros. But then this one doesn't start over yet because we haven't gotten to the end. Oh. Okay. This is tricky math. Look at the formula. I've been staring at the formula. Yeah, I'm sorry if this is frustrating. It's like, I know the answer, why can't he figure it out? Yeah, 4 goes into 10,000, but 8 does, but 12 does not. Why is there always an 8? Oh, yeah, because they're all zeros except for the last one. That makes sense. It's just going to be the last digit always. Right. So, I feel like if we know the pattern, we can figure out what the digit will be based off of what frequency it is. So it's these frequencies specifically. So there's going to be that many zeros, right? Yeah, there's going to be that many zeros and then 8 ones. So it's just going to be 1 times... Yeah. Yeah, they're all zeros. The bottom left, the one half of them are all zeros, right? This pattern. The first one is going along a diagonal. Oh, but we're not on that row, though. Wait a minute, let me think about this. This is not the output. This is one row. Shoot, this is tough. If it weren't for the weird module, you could actually use some more complex maths. Yeah, it is based off of the FFT. The answer is 345,735. I don't know if that's true. Actually, the answer has to be an eight-digit number. 8-digit number. Not 6. I'm just gonna ignore the 10,000 at first. I'm just gonna do for one iteration. What if it's a huge square, and I only cared about that rows? Really, I need to know those columns. Well, that row, right? So it's going to be just that digit, right? Just this digit in this repeating sequence. Yeah, it's just going to be a sampling. Okay. And then what do I just, then what if it's the second phase though? I need the, let me think about this. I need the entire previous row though. I was wondering about that. Is it just like removing all the zeros, for example? I'm trying to think of if this is the actual nut column, I'm just trying to reduce it down. Let's say I only wanted to know the 7th in the last phase, right? And let's say we only did four phases or 3 phases. 4 phases, right? So we wanted to get 9. To know 9, we needed to know the 1 and the 8 from the previous. So the 1 and for those two, we needed to know the 3 and the 8 from here. Oh, that's interesting. So we really are restricted to just that. We can skip all the zeros leading up to it the whole time. Aha. Okay. Cool. I think I'm getting there. So I need to know I need to calculate from that to that, don't I? For every previous phase. So to get that 9, it's 1 times this is 1 plus 8. That 9 is 1 plus 8. And that 1 is 3 plus 8 modulo, and that 3 is 5 plus 8 modulo 10. So I've effectively skipped all of these rows completely. So I could do the same thing in my real solution. I can skip all rows 0 through that minus 1, but I still need to get, so I still need this through 6, 4999999. That's a lot of columns still, right? It does reduce it by an order of magnitude, though. So what is that minus that? It's 522,622. That's still a big one. That times 10,000. It's still a lot of calculations I gotta do. I gotta do 5 billion calculations. But it is on the order of something I could do. And maybe I can take advantage of the fact that it's repeating, too. How do I take advantage of it being repeating? Let's say it's repeating every other one. So 3 and it's like 1 2 1 2 1 2 1 2. Let's say I needed the last 6, or I need this 9. So that means I needed the 5 5 1 and 8. Yeah, and then each of those is just, oh, you know what? It's just 8 plus 3 plus, it's walking the diagonal. It's just walking the diagonal and adding them, isn't it? And then compounding as we're adding. So it's 8 plus 8 plus 3 plus 8 plus 3 plus 4 plus 8 plus 3 plus 4 plus 0. So we can just keep the rolling thing and just modulo 10 add, modulo 10 add, modulo 10 add. Okay. This becomes doable, doesn't it? Okay. Let's see if I can try to put some of this into practice here. You think I have it? I don't know if I have it. I really feel like I'm standing out on a limb here. We're not going to do the FFT that many times. We're still going to need a certain number of iterations. But, yeah, we're still going to do the same number of iterations, but we're walking the diagonal, aren't we? Hold on, let me think about this. We're skipping a bunch of rows. Hey there, Cthulhu. I'm figuring out difficult maths. Oh, and hey there, Ruffiano. I forgot to say hi. And PFG Twitch. And N Perry, I missed you. Where did you say hi? N Perry. Is that a while ago and I missed it? It was at 12:28 and then at 1 o'clock. Yeah, sorry. I missed you. I failed. I failed you, N Perry. I'm sorry. I'm doing difficult math though. Don't I get a pass because of that? Beast is yelling at me. What do you want? Kitty, kitty. He's just standing. He's standing over there, like meowing at me from like 10 feet away. All right. Let me try to get this right. We skip that number. So let's say the number was 3. Then we would skip. We would want the 4th one. So we would want this 2, which is oh wait, hold on. It's not as easy as I thought. We can't just do the 1. We have to keep going a certain distance. Shoot. I thought it was going to be easier. Yeah, so it's not just the walking the diagonal. Is it? Dang it. Must do my 24-hour stream doing math right now. That sounds like hell. Okay, I messed up. I thought I had an idea, but I still need all of those columns, which is I mean, I still need all of that, which is a lot, right? Um, really, it's I don't know why I have that number. It's that minus that. What is that? I need to do 522,623 potentially ads. Or do I? Yeah, it's gonna be, that is much less than that. So they're all gonna be plus ones way down at that column. But I will need to add a bunch of things together, won't I? So like this entire thing. From that all the way down, actually, how many do I need? I need it all the way to the end. I need to add together 522,000 numbers. And from there, actually, if I'm only walking up, I'm walking up the diagonal until all the way till I get to the top, right? So it's actually adding together a huge shape that includes a bunch of stuff that I don't have. Damn it. It's harder than I thought again. If it was at the right edge, it would be easy. But it's not at the right edge. It's 522,000 numbers away from the right edge. So you thought I had it, but I don't actually think I have it, unless I'm missing something simple and I'm getting off the track again. Because it's like this. Let's say we needed to add these numbers together, right? Sure, we can do that, but then I don't just add 4, I have to then subtract 1 and 5. And then I can add 3, but then I have to subtract 1 and 5 again. And then subtract these again. I'm missing a key piece. Yeah, I figure I'm missing a key piece. I'm wondering if it has to do with the fact that we're repeating. That, I can't wrap my brain around it. Don't actually need that piece. What am I missing? There are 2 ways to solve it. I figure that there's more than one way to solve it. Okay, I could just look at one iteration. It doesn't really matter how many iterations I do it. Well, yeah, ultimately I could just brute force it and then do a lookup, and that would take what, millions of years? But yeah, I'm just joking. Shoot. Okay, so what if I start at the input at that offset, and then I just add up all the ones all the way to the end, because we know we know what that it's that frequency. So they're all going to be added together, and then we're going to march upward from there, reducing the frequency until we get to 0. And along the way, we just have to adjust it, right? Like this example, it's 7 plus 8, and then walk up, it's 6. So we're just adding, and then at this point, now the frequency is less than the row number we're on, and so we have to start subtracting. Subtract another one, and then actually it's 2 more, and then that's 1, 3, 5. Is there a pattern here, or am I not, or am I just deluding myself? it has to do with this shape, right? This is a diagonal, and then where are the ones? Where are the ones and the zeros? Oh, it's a slope of 2 to the right, 1 down. What is that? One half slope. That's a slope of 1. That's a slope of 1/2. And then where's the next cross? 1/4? And then 1/8, 1/16. I don't think he's giving me spoilers. Hey there, Manure Play. Oh, you're back, huh? You were here 3 hours ago. At the beginning. I'm kind of stuck, though. Thank you for the follow, PFG Twitch. I don't know. I feel kind of bad, though, that I'm kind of stuck on this. This is like yesterday. I got stuck, and then I was about to give up a few times, and then a light came on, and I'm like, oh, I can break this up into smaller problems. All right, so let me just try something here. So, extract the offset. Had to compile a large project, so you needed all your CPU power. You couldn't watch me, huh? Or you're just addicted? Could be. So the offset is going to be const auto. It's 8 digits. They said, right? How do they say? How do they say it? I want to do it with a smaller example. Okay, they did it purposely with a 0 to make it work. Anyone hates Java here? Here. Offset is oh, it's 7. Okay, well I can just hard code this. I can say digits 0 times 100,000 plus digits 1 times 10,000 plus digits 2 times 1,000 plus digits 3 times 100 plus digits 4 times 10 plus digits 5. That's not correct, is I need to add another 0. That's a 7-digit number. So there's our offset. Then I can work... Hold on. If it was just one phase, then I could just work from that column and get one number. Working backwards. No, that's not what I can do. I'm just about to give up on this one. What's this used for? It's just part of Advent of Code. It's just a puzzle. Trying to solve a puzzle. It's sort of a joke on fast Fourier transform, which is frequency analysis. So it's taking a signal and getting its amplitude of different frequencies of sinusoids in there using convolution, but it's not exactly. They're doing truncate. They're doing modulus, and they're iterating, and so it's like it's different enough that you can't actually use a real FFT to solve it. This is hard. We were just doing 2 phases, and we only needed the digits 43. Then I would be going to that, right, adding up 1 to the end there. That's the 4. And then I'd be subtracting 1 to get the 3. But to get that, I needed... I see. I needed the 1, the 5, and the 3. Okay, so... Right, so each phase, what we'll do... We have to still do it in phases, but we'll start at the... at that column and just add them up. Get a number, then... Actually, I guess we start from the right and go left. That's the 8, plus the 7, plus the 6. Okay, so then I can start from the offset plus 8, right? So apply a strategically small part of the FFT many times. And they talk about doing this 10,000 times, right? In the examples they get. No, it's still 100 phases. No, hold on. Part two. Oh, it still is only 100 phases. Okay, so the 100 phases is still true. Okay, so we don't have to... It's going to be repeating anyway, right? The first one is. I might as well reserve the whole memory though, because why not? It's how big is it? Just 6 million. So let's go ahead and make it. Let's just expand it. I probably don't need to do this, but reserve order times 10,000, and then we're just going to do this 10,000 times. And then that way this will be 10,000 digits, 10,000 times 650 long. And so instead of doing this though, we're going to start at offset plus 8. Right? Nope, offset plus 7. And I'm going to go to order times 10,000. I should actually go backwards, shouldn't I? Yes. So, and I'm going to have a sum that we're accumulating here. So we're going to start at that minus 1 greater than or equal to offset minus j. And I don't need to do that anymore. It's just a sum plus equals digits j. I need to actually the name. Oh, thank you for that follow. I need 2 variables, don't I? So let's call it inner and outer. Inner, outer. So the inner sum did I forget to add 8? No. Yeah, I did forget. This is the inner loop actually. Or no, that's we can right, I got it. Hold on. I'm getting myself confused. We're going to go until it reaches offset plus 7 and add them up. And then we're going to go from offset plus 7, no, plus 6, j is greater than or equal to offset minus minus j. And we're going to say outer plus equals inner, and inner plus equals digits j. So this is calculating like if we wanted to get this 4 and this 3, we're first getting the 3 by starting from here and just adding all the way to the right. Or basically adding from the right to the left. Take the 8 and add the 5, right? And then we're going backwards 1 more and taking that 3 and then adding 1. And then we get that digit. And then we're adding it to the outer because I'm using that where did I decide I was going to use that? Actually, I guess I don't need that outer at all. Those are just the output. Oh, is it because it's using the previous? Or in the next phase? Yeah, it's used here again. So I don't need to I just need to save them to use them in the next iteration. That means actually I have to start at the end and go all the way back up, don't I? Oh, shoot. I'm getting tired of this. I think the cat knows I'm getting tired of this. He's like standing there saying, "Are you still trying to fix that problem? You haven't given up yet?" I think I need a break from this problem. Can I like look at day 17 and come back to 16? I'll stop the clock and mark time in progress. How about that? 58. Oh, 59. We'll just say I spend an hour on it and then I stop. Don't worry, the next day is easier. Good, because I need something else. I'll come back to this problem. I'm just fed up with this. So let me just check in this. I need to make it actually build. I'm not going to end up running it though, so let's do that. Make sure it builds. I'm not going to actually run it though. Okay, and I'll just check it in. Work in progress. Work in progress. Adding solution for 16.2. What I want to say here, I'm stuck trying to reduce the problem space to a manageable level. Yeah, it would be helpful if I actually staged all that. Commit. Push it. Alright. Let's move on to 17. An early warning. Oh, stop the clock. Start the clock. Okay. An early warning system detects an incoming solar flare and automatically... Oh, thank you very much. TS Jost farming those points again. 17.1. We gave up on 16.2. Detects an incoming solar flare and automatically activates the ship's electromagnetic shield. Unfortunately, this has cut off the Wi-Fi for many small robots. That unaware of... Oh, we're going to use the int code. Cool. Unaware of the incoming danger, now trapped on exterior scaffolding on the unsafe side of the shield. To rescue them, you have to act quickly. The only tools at your disposal are some wired cameras and a small vacuum robot currently asleep at its charging station. The video quality is poor, but the vacuum robot... Oh, hold on. I gotta take a quick break. Sorry about that. That was the cat coughing up a fur ball. I wanted to make sure it wasn't on the carpet. When you have a cat, and you know the sign that they make that they're going to, you know, it's about that time. Oh, you like the shirt? Whatland shirt? Anyway, back to business. The video quality is poor, but the vacuum robot has a needlessly bright LED that makes it easy to spot no matter where it is. The encode program is called the Aft Scaffolding Control and Information Interface, also known as ASCII, provides access to the cameras and the vacuum robot. Currently, because the vacuum robot is asleep, you can only access the cameras. Running the ASCII program on your encode computer will provide the current view of the scaffolds. This is output purely coincidentally as ASCII code. 35 means a hashtag, 46 is a dot, 10 starts a new line of output below the current one, and so on. Within a line, characters are drawn left to right. In the camera output, hashtag represents a scaffold and dot is open space. The vacuum robot is visible as one of those characters depending on whether it's facing up, down, left, or right. Got it. When drawn like this, the vacuum robot is always on a scaffold. If the vacuum robot ever walks off of a scaffold and begins tumbling through space uncontrollably, it will instead be visible as an X. In general, the scaffold forms a path, but it sometimes loops back on itself. For example, suppose you see the following view from the cameras. Here the vacuum robot is there. It's facing up and sitting at one end of the scaffold near the bottom right. Scaffold continues up. Oh, I see. Loops across the sill several times, ends up on the bottom left. Got it. It's not hashtag? Just hash? Okay, I'll try to say hash instead. The first step is to calibrate the cameras by getting the alignment parameters of some well-defined points. Locate all scaffold intersections. For each, its alignment parameters, the distance between its top left edge. No, between its left edge. I don't know why I saw the word top. Between its left edge and the left edge of the view, multiplied by the distance between its top edge and the top edge of the view. So it's just x times y, basically. So the top end is 2, so it's 4, right? And that one is 8, got it. 6 from the left and 4 down, so it's 24. That makes sense, 40. You need the sum of the alignment parameters. Okay. I got to run the program. The program will output scan lines. We got to collect those and look for intersections. And, okay, I got it. So an intersection is basically where there's any hash, where there are 4 hashes near it. That's an intersection. That's easy enough. And I have to consider that the robot is standing on a scaffold. So if I see one of those 4 things, then treat it like a scaffold. Got it. Okay. All right. This one's more fun. I don't know if I ever get back to 16.2. Probably. I can't let it be the only puzzle I didn't solve. So let's take 15.1 and copy it. 17.1. 17.1. And I have about half an hour left before I gotta go. Don't know if I'll get this done. We'll make an attempt. 17.1. Wrong thing. 17.1. Hold on a second. I gotta tell someone something. All right. Cool. Just had to alert someone about the fact that there's a hairball somewhere. Not just don't step on it. I made sure it was not on the carpet, so it's easy to clean up. Anyway, enough about that. Let's see. I built it. I should get the int code program ready. That's the puzzle input. Here is the program. Program goes there. Copy the program. 17.1. All right. I have a feeling we're going to use the pathfinding soon, so I'm going to leave it in there. Okay, cell we can use. Or do I want to use cell? Maybe I just keep it simple and use characters. That means I'll, where we had cell, I'm just going to use char. Actually, let me just leave that cell in there. Because it's kind of coupled with the functions that I had for the pathfinding up around here somewhere. Just go down to the bottom here. So read it in, construct the machine. So I guess we go until it halts and it prints out something, right? So construct the machine, run the machine until it halts. The machine output is drawing an image from a video camera. So we're gonna get the image as a vector, a map actually, from position. Well, do I need it to be a map? It'd be easier if it was just a vector of vectors, right? Of characters. So image, and then we don't need that. We're going to say while not machine, too many knots. While not machine halted, it doesn't have any input, right? I mean, I guess there's no input, so that means it's going to halt when I just run it. So machine.run output. And where was output again? Here it was. Okay, so I don't need any of this stuff, right? We could display it. Maybe that would be the first step. We're going to display it. Display the image. So, actually, we need to process the output to get the image. So, for auto, character and value and output. Actually, it's going to be a character, right? It's just we need to convert it into a character. So, const auto, actually, let's just call it value. Const auto ch is character value. If, well, we can short circuit it. If value is 10, then it's an end of line, right? So let's build a line here. Image push back standard move line, image line, and image line clear. All right, and then continue. Otherwise, it's something to put into the image line, right? Image line push back character. And then this will go basically for const auto line in image. Actually, let's just put image line back in here. Printf. Wait a second. At the end, we're going to print a new line, but in the midst of it, we're going to do for auto character and image line. Printf character ch. All right. Let me just see what that gives me. Oh, nice. Look at that. So it's sitting way up here, and there's a whole bunch of twists and turns. Got it. Okay. So cool. We got a display for it, and now we're going to count, well, find intersections and sum their, what is it called in the instructions? Alignment parameters. Alignment parameters. Printing the map is refreshingly easy this time? Yeah. So I think I'm going to do the same thing. No, wait a minute. I have a better idea. We'll use coordinates. So const auto height is image dot length. Const auto width is image 0 dot length. For size ti, y is 0. Actually, it has to be start at 1 and be less than height minus 1. Can't have an intersection that's on an edge, right? And length is size instead, right? Okay, so for size t, x is 1, x is less than width minus 1 plus x. Is image line a string? If so, what about printf? It's not a string, it's just it's a vector of characters. So that's why I'm doing that instead of a printf a string. So actually, you know what? We could do this before we display the image, because we can put an O there if it's an intersection. So if image y x minus 1 is one of these. Actually, we're going to have a bunch of characters that count as a scaffold. What if we have two things adjacent? Can you have two adjacent intersections? It doesn't look like it. So I don't have to worry about an intersection being right next to another intersection. Okay, so I don't need to worry about that. But there are other characters that we might need to search for, so let's just say const. Can I do const expr for a string? Scaffold characters is that, but then also these ones, right? Which character is that? It's lowercase v. And that's caret, and that's, okay. Because those, wherever the robot is sitting, counts as a scaffold character, right? So I would say, actually, this would be easier if it's a static const standard string. If scaffold characters find this, it's not equal standard string no position. We're gonna have 4 of these actually. Then it's actually there needs to be 5, isn't there? We can skip it if it isn't itself 1, right? If it's not a scaffold 1, we can just continue. Actually, we just build it in. Doesn't matter. There's 5 conditions. It has to be itself a scaffold, and there has to be 1 to the left, 1 to the right, 1 above it, and 1 below it. Then, image y x equals, what do they use? Capital O. Let me do that much of it first. There we go, we found our intersections. So it's not corners, it's only intersections, right? And we didn't miss any. Cool, so then we just need to calculate the, whatever they called it. Alignment parameters. sum of the alignment parameters. So let's just get a sum here. Int sum. Sum plus equals x times y. Print it out. Sum of alignment parameters is that sum. Wrong one. 5,788. Yay, I got a gold star. Was I running my, yeah, I was. 17 minutes. Ooh, I have a warning here. Oh, because those are size T's. Well, let's just make the whole thing size T. ZU it is. "17 minutes. Yeah, I gotta go in 15 minutes. I don't know if I'll be able to get the second half of this. I'll at least read it. That looks nice, doesn't it? Looks like I have an extra blank line at the end there. Yeah, I won't forget this time. I haven't started, so no points can be gained. Yeah, you're trying to steal points from... I see this strategy. Trying to keep TS Just from scoring too many points. Okay, so this is add... Whoop, I can't do it. Add solution for puzzle 17-1. Commit. Push that. Clear this. Go to current task. Sorry, TS Just. And say we're doing 2 now. Start. Not rude. It's all's fair in the point competition, right? Oh, don't quit. So you're so good at reminding me. Now for the tricky part. Uh-oh. Notifying all the other robots about the solar flare. The vacuum robot can do this automatically if it gets into range of a robot. However, you can't see the other robots on the camera. So you need to be thorough instead. You need to make the vacuum robot visit every part of the scaffold at least once. Visit every part of the scaffold at least once. Vacuum robot normally wanders randomly, but there isn't time for that today. Instead, you can override its movement logic with new rules. Force the vacuum robot to wake up by changing the value in your ASCII program at address 0 from 1 to 2. When you do this, you'll be automatically prompted for the new movement rules that the vacuum robot should use. The program will use input instructions to receive them, but they need to be provided as ASCII code. End each line of logic with a single new line. First, you will be prompted for the main movement routine. Main movement routine may only call the movement functions A, B, or C. Supply the movement functions to use as ASCII text, separating them with commas, which is a 44, and ending the list with a new line, 10. For example, to call A twice, then alternate between B and C 3 times to AA, BC, 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 then a new line. Then you'll be prompted for each movement function. I'm being subbed to. Hamada. Thank you for the subscription. Thank you for your support. Movement functions may use L to turn left, R to turn right. Yeah. Look at you. You got a nice bronze or copper gear there next to your name now. It's going okay. I'm doing Advent of Code, and I got stuck on day... What was it? Day 16, part 2, after an hour. I kind of just gave up. I'll come back to it sometime. But I've done all the other puzzles before that, and I've almost caught up to 17 is the last one we have today, right? Yep. And another 7 hours, 18 will unlock. So I'm doing the last puzzle that we can see. And I don't know if I'll have time to do it because I have to drive somewhere in 20 minutes. But at least I'll read the instructions here, and then so I need to finish this one and then go back and do part 2 of 16, and then I'll be completely up to date with Advent of Code. And in case you want a link, there's the Advent of Code. I'm going to keep it at made it to day 16 because I technically haven't finished day 16. All right, so L to turn left, R to turn right, or a number to move forward that many units. So a number in ASCII? You did day 1 and 2, but haven't gotten around to carrying on just yet. Day 2 was kind of tough for me. Some of them are easier than others, yeah. Movement functions may not call other movement functions. Again, separate the actions with commas and in the list of the new line. For example, to move 10, then turn left and move 8. It's 10, left, 8, right, 6, and then a new line. So what's A, B, and C? What the heck is an A, B, and a C? Oh, there's a routine. Okay, so we give an outer routine, and then we provide what is A, and then what is B, and then what is C. Got it. The example makes it clear. Okay. Finally, you'll be asked whether you want to see a continuous video feed. Provide yes or no on a new line. Enabling a continuous video feed can help you see what's going on, but it also requires a significant amount of processing power. That may even cause your encode computer to overheat. Oh no! Due to the limit, probably that means it will crash early, so it won't. You can't get to the solution, but you can at least use it for debugging. That's my guess. Due to the limited amount of memory in the vacuum robot, the ASCII definitions of the main routine and movement functions may each contain at most 20 characters, not counting the new line. There's the camera feed. In order for the robot to visit every part of the scaffold at least once, one path it could take is right 8, right 8, right 4, 4, 8, left 6, left 2, right 4, right 4, right 8, right 8, right 8, left 6, left 2, right. Without the memory limit, you could simply supply this whole string as A, and then have it call A once. However, you'll need to split it into smaller parts. Ooh, this is tough. One approach is A, B, C, B, A, C, where it is right 8, right 8, right 4, right 4, right 8, left 6, left 2. Oh, I see. So we're looking like we need to find a path and then see if we can break the path into subroutines and have at most 3 subroutines. And then I guess both the subroutines and the outer can't be longer than 20? Yeah, main routine and the movement function. So everything has to fit within 20 characters, not counting the new line. So the overall has to be less than 20, and then each subroutine has to be less than 20, or no more than 20. Of course, the scaffolding outside your ship is much more complex. Of course it is. We saw that what it looked like. It looked like that. That looks like a mess. As the at most 20 or less. Yeah. As the vacuum robot finds other robots and notifies them of the impending solar flare, it also can't help but leave them squeaky clean, collecting any space dust it finds. Once it finishes the programmed set of movements, assuming it hasn't drifted off into space, the cleaning robot will return to its docking station and report the amount of space dust it collected as a large, non-ASCII value in a single output instruction. So we only get... I see. We get video output, but when it gets to the last one at the end, we'll also get an extra output, which is the answer. I get it. All right. So, right, we did the A routine, and then B. Oh, it's 448, right? 448, and then C is a special one, and then 448, and then another A, and then C fit there again. Got it. Wow, that's really difficult. That's hard to do, isn't it? We're going to want to look for the longest repeating pattern, right? So here it was right 4, right 4, right 8. And then once it removed that out, it was left with a bunch of right 8, right 8s. It probably found that next. And then the other one it was left with. That sounds really difficult. I'm not gonna have enough time to do this, I think. You'd say it's easier than 16.2? Yeah, I mean it's doable. But it's several different problems, right? We first have to find a path that hits every part of the scaffold. Actually, I guess we have to solve these all together. You have to find a path, and then you have to break the path up into subroutines. Ooh. So what's one way we can analyze this? I think one of the hints is that the first half of the problem is talking about intersections. It made a point of us calculating where the intersections are. I'm guessing that's important here because we're going to want to make a decision at each intersection where we're going to go, right? We could either keep going, and that would be part of the move to get there. Actually, we're not forced to do that. We don't have to, no, we have to turn left and right, don't we? We can all, no, we can move forward and then move forward again. So when we get to an intersection, there are 3 things we could decide to do. We could turn left, and then we're going to move, because otherwise it doesn't make sense. We could turn right and move, or we could move again. Unless we're really tricky, we could do 2 turns, like 2 lefts. Why would we ever want to do that? If we need to turn around, would we ever need to turn around? Probably not. So we could restrict it to be we're either going to turn left, turn right, or yeah, we might move to the intersection and then move again if doing so helps us find a larger subroutine, I guess. Always need reverse? This one didn't need reverse. Does mine look like it might need reverse? It's when you get to these intersections, right? And one thing we know for sure is that we have no choice. The first one has to be a 1, 2, 3. It has to be a 4. So we have to start with the 4 and then a right. 4, right, 1, 2, 3, 4. Well, I guess we could break this 4 into smaller steps if we needed to. No reverse, never mind, yeah. Just thinking, how would we do this? When it gets to these intersections, it's kind of unclear how to draw it. I guess we can make the assumption that we always go through an intersection. So if that's true, then we would always go down, and then we would always go through that one, through, down. Yeah, okay, that makes it a little bit easier. We never turn at an intersection then. Although, what do the rules say? Does that be at least once or exactly once? It's at least once, so that's the trick. We could end up coming to an intersection and actually turning at the intersection if it helped us to find a solution. We need to keep that open. The bottom right looks very crowded. Yeah, so we'll come into here. We'll go basically in a loop or 2 and then come out. Unless, like, it could come through here and go around the boundary first. There's nothing that says it can't. And then go in here, and then go over here, and then down, and then totally reverse back out, right? I'm going to make the assumption that I can get away with the simpler thing of always going through an intersection. And then reduce the problem down to, we know what the path is, we just have to make it fit into 3 subroutines and an overall program. So, do they have another example? They just had one example. How would I split, if we came up with that, how would we split that up? I think it's finding the largest substring that's repeated. So, just naively, right 8 matches there and there and there, and then if we're really aggressive about it, we can get right 8, right 8, right. Right 8, right 8, right again here, right? And then we can just try to fit that as a subroutine and then see what we're left with. Let me walk through this. I think I'm not going to be doing any more coding because I only have 8 minutes left, but I'm going to do some thought experiments here. If we had that, and let's say we picked that as subroutine A, then what would we be left with? We would be left with A Let me just take this and abuse it. So that appears twice more, right? A. Enter. Okay, so then we have these two fragments left over, right? So what are some other common things we can pick out? The 4R is in there. But we can find a longer one, right? 4R4 is repeated. But not 4R4R. R4R8 is not repeated. This is how your map looked. Huh. So how does that compare to mine? Looks like they just made some crazy turns, like a random walk. They just did a random walk, right, for a certain number of steps. Yeah, I was thinking about that last night. Like, how do people come up with these puzzles? And some of these puzzles, I thought they'd be hard. It would be harder to come up with the inputs and outputs than it would be to actually solve for them. I think this is the one that's common, right? This one's also 5 characters, so this one is going to say B equals that. Whoops. And so we end up with that becomes a B. Whoops. That becomes a capital B. Got it. So then these are the fragments we're left with. 4R, 4R, and R4, R4. So then this won't work, right? Because we have, we can't fit that into a subroutine. So then I guess we would have to back up. So I guess we could just a brute force approach would be to try all the subroutines until we get it to fit into exactly 3. So like at this point, it would back up and try a different B. Maybe the next lowest match, it would like try 8L, 6L. And so we would end up with 2s left over. Let's see. So if that is replaced with B. Oops, not everywhere. Just the next match. And then we have another problem where we have a 2, and then so that's even worse. So undoubtedly it would end up, if there's only one solution, it would end up trying that instead. And so that would go to A, enter. And then how did they pick R? Oh, there was an 8 in there. I didn't see that. Oh, did I mess that up? I think I did. Oh, yeah. That could be split in more than one place. So that becomes an A, and then this one becomes an A, and then it does that. So then we have R4, R4, R8 comes in twice. So it reduces it down to that. And then that's the last subsequence. And they can't call each other, can they? They cannot call the movement functions. All right. So I suppose the approach I would try to take, which I'll do next time I get to work on this, is just try to find the longest, or just try to find any subroutines. And we only have to do 3 steps to see if we can if we succeed or not. And if we fail, then we'll just throw it in. We'll take that path and just abandon it and find all the other paths we could take. So it's kind of like a pathfinding. Only the course we take is what we put into a subroutine. And we would just find the path through this. The path is the subroutines to make, right? And then we would program it in and do it. So I think I have an approach. You can be too greedy. Yeah, sure. We can be too greedy, and then we would just back up. So that the greediness would be sort of the heuristic, so to speak. That if we have a better chance of finding good subroutines by being greedy, we could try to find the longest repeating pattern first, and try that first, and then we get to the solution quicker. So that's going to be my approach when I come back to this. I don't know when I'm going to have time to do it. Maybe later tonight? Maybe tomorrow? But that's the approach I'm going to try to take to solve this. So I have to solve that, and then I have to solve 16.2. So let me stop the clock and say I've worked on this for 20 minutes. So I think I can solve that. I think I'm going to try to solve that when I get back. And then I just need to crack my head on this one and get a solution to that, and then I'll be caught up. And if I can do that in the next 7 hours, and then I can do 18 with everybody else in the world. Otherwise, I'll be still behind one day. The main program is always in the form A, B, Is that right? They have A, B, C, B, A, C. I guess well, does it always have to be? You could have A twice if the beginning of it is, maybe it does 2 turns or something. So less than 64 squares, you can use bitmasks instead? I don't think so. It's a lot. Oh, you're saying the whole maze? I'm not printing out what it is. I think it's less than 64, at least wide. You're talking about optimizing it now. Anyway, I think I'm gonna have to call it because I have to go. It's 2 o'clock in the afternoon my time. I have to go, so sorry, I gotta end a little bit early. Let me wave to the people who just came in at the end. Hi, Meme Clear Bombs and Doc. Let's go raid someone, and I don't know if I'll be I guess I will be streaming. I might be streaming later, or either later today or tomorrow. I'll try to at least get 17.2 done. And try to find someone good we can raid right now. Okay. No one I know is doing Advent of Code. Maybe I should search, though, for Advent of Code instead of following. Advent of Code. Well, there's me, and then there's someone else with 6 viewers. And then that's it. Should we just raid the other guy who's doing Advent of Code? Let's see what he's doing. Let's see if it's in English. It says it's in English. I'm watching an ad right now. Okay, it's in German, though. If they're speaking English, I'll raid them. Let's see. Achtung. Actually, what one are they doing? Compiler says 9. They aren't speaking, so I'm waiting for them to say something. Yeah, they do have German English. I can't even tell what puzzle they're on. Maybe they're on, well, one thing that's different is it's in Python. I guess we'll raid them. Why not? All right. We're going to raid this person. I have no idea who they are. Never seen them before, but they're working on Advent of Code also. And I can't even figure out what really puzzle they're on, but they're doing it in Python, so it's a switch up from what I'm doing. Okay, and they are speaking English, so that's good. There we go. Starting the raid. So when I get back, when I have a chance, I'll try to get 17 and 16 done. In the meantime, I hope you guys have an excellent rest of your day, and thanks for being here. Bye.